So I think we will start. Good morning, everyone. Welcome to this 149th edition of the Zak World of Façades conference here in Miami today. It's our first one in Miami and Florida, but almost our 11th or 12th one in the United States. My name is Ahmad. I'm part of the organizing team here at Zak. I'll quickly introduce the conference series to you guys since it's the first time happening over here. Can we have the screen switched, please? Yes. So we've been organizing this event since 2012. Started it back home in India. It was a small networking event, but then it's grown globally. We do this event in almost 65 cities around the globe, in almost 40 countries as on date, and to touch 44 countries by end of this year. They spread all across from New Zealand up until Canada. And all these events are different because every region, the way facades are designed, engineered, installed is completely different. So for us, we customize bespoke agendas which are relevant to that respective city, to that respective region. So keeps us on our toes and also makes us take ideas from one region to another region. We have a straightforward agenda today, 3 sessions. We have a post-event reception at the end of the day. I'll come to that at the end. But I'd just like to start off by thanking our sponsors, without whom this event wouldn't have been possible. I'll start with AGC Chemicals. So this is the chemical division of AGC. They've got fluoroploramides and a couple of other chemical products which are used in different products which are used on the facade, on powder coatings, on liquid coatings, on ETFE and things like that. All our sponsors have our tabletop booth. All our associate partners have a tabletop booth outside, so please do visit them in the networking break or at the end of the day during the post-event reception. Amico, Alabama Metal, they've got expanded mesh and other solutions for the facade. Exalta, one of the world leaders in liquid and powder coating solutions. Cosentino, Spanish company, they've got an interesting non-combustible cladding product called Decton, which is picking up a lot of traction now globally on the building envelope. Envilon, they are a German company. They've got BIPV, Building Integrated Photovoltaic Solutions. ES Windows, ES Group, need no introduction, one of the leaders in glass processing, in aluminum fabrication, and everything they do in this side of the world. Glassbell from Lithuania, one of the leading value-added glass processors out of Europe. Guardian Glass, again, need no introduction, one of the leading coated glass, global coated glass manufacturers. Crisca Decor from Spain, exhibiting with us for the first time. They've got some innovative solutions which can be put on the facade as a second skin for decorative purpose and shading purposes. Curare is the mother company of the laminated glass interlayers, Throsifol and Sentry Glass. Longboard, they've got a lot of cladding products, ventilated cladding, shading, and a lot of other aluminum cladding products. Neolith from Spain, sintered stone, another new engineered cladding material picking traction up in the external facade. Onyx Solar, another Spanish company, they've got a transparent BIPV, Building Integrated Photovoltaic Solution. Optimum Steel Windows here from the US, they've got some interesting steel window solutions. Rayner's Aluminum, one of the global leaders in aluminum domed window and curtain wall systems from Belgium and present here in the US and Canada. Saflex is part of the Eastman Group, so they are an interlayer company for laminated glass. Sedac, one of the leading value-added glass processors, specialty in jumbo and curved glass. Soydrice is a British manufacturer. They've got cavity barriers for curtain wall perimeter protection and rain screen fire stopping solution. Stowe, a German company, they've got a lot of innovative non-combustible cladding solutions. Tactile, American company, UHPC Solutions, ultra high performance concrete, another next generation material which is again picking up a lot of traction. Techfire, a Spanish company, they're into fire rated solutions for interiors, for doors, windows, and curtain walls. TGP, Technical Glass Products, again a fire rated glass systems solution provider. Turkish Glass is the association of the Turkish glass processors. So Turkey is known for exporting their aluminum and glass solutions across the globe, and Turkish Glass is the voice for all the Turkish glass processors overseas. Our delegate kit partner, so those who have the red lanyard have a delegate USB stick. The USB has the brochure of all our sponsoring companies. That USB is courtesy Slim Pack, which is part of Fourglass. And then post the event, we've got a 1-hour reception after the event ends in the exhibit area. That's courtesy Ekasali Okalahan and Kurare. These are our 2 reception partners. And of course, today's program and agenda is on this booklet, courtesy Paramount Consulting Engineers. So they are the agenda partners for today. We've been doing these events globally. In North America, we've been growing since 2017. Originally, we were a New York-only event, but we have a local team here now, and we're growing the event. Our next event in the region is in Toronto, which is actually next week, which is our second event in Toronto. We've got Austin in June, which is our first time going to Austin. Vancouver, again, one of the fastest growing cities in North America. We are returning there for the second time. We had a fabulous first edition last year. And of course, the biggest one in North America and the second biggest in our global series after London is New York. That's a large event. It's a 3-track event with almost 60 speakers and 60 vendors displaying their solutions on the day. So that's the biggest one and our second most high-profile event globally. So that's it from me. I won't take too much of your time. Just those who are coming now, we've got seats here if you'd like to get seated. I'd like to call upon today's event host and convener. He's someone who's been extremely instrumental in supporting the Zak World of Façades conference series in North America during its inception time. Attila Arian, he's right now the managing director of NR Group. Earlier, he's been at several multinational companies, well-known figure in the glass, facade, aluminum segment here in North America. He's going to be steering you through till the end of the day. He's a pro at this. This is his 5th or 6th one, if I'm not sure. He's mainly done it in New York and now for the first time here. And one more thing I forgot. So we've recorded today's event. So we the permissions which we have received from speakers to share the recording with, all of them would be put together on a YouTube link and would be shared a week from now with you. Thank you all, and I hope you enjoyed this first debut edition in Miami. We've got a great agenda, little tight, little packed, but the content's fabulous. You're going to enjoy it. So thank you all, and Attila, over to you.
Good morning, everybody. And thank you very much, Ahmad, for the nice introduction. I didn't realize that I was so instrumental with the Zak conference, but I do have a lot of appreciation for it. And I do have the pleasure and the honor of walking you today through the program, which I think is a phenomenal thing that the Zak conference has put together under Susan's leadership. We have been cooperating a little bit together on this thing, but I think it is addressing the 3 main topics that we have here in this market. This Miami is a vibrant and dynamic real estate market, which is now putting us all within the building envelope industry in front of 3 main challenges. Number 1 is that we have the implementation of contemporary architecture to master. Secondly, we have to deal with very high performance criteria, not only the impact rating. And then we have some of the lowest budgets in the country for the work here, which has essentially led into a one-horse town. So if you're looking around, there is only one company that is supplying the window walls and the curtain wall. God bless them that they are doing this, but these are things that are challenges to our industry, and the program is tackling each and every one of them, which is great. On a housekeeping note, Ahmad addressed the topic of the reception. We have also the ability to give you AIA credits. You need to register on your way out for it. There is a special desk for that. And then we will have lunch, and during lunch, the hotel is asking, and we have to kind of make that announcement, that you don't come with your lunch into this room. So you stay where the lunch is served as a courtesy to the hotel organization. Having said that, let's start right away and put the show on the road. Our first speaker will be talking about a very, very vital topic, and that is, how do I get all these charismatic architects under control and build a project that essentially is buildable and passes through the whole, let's say, administration that we are, and some of the red tape that we have to deal with here. So the role of the architect of record is something that becomes very, very critical for a lot of the projects that we are seeing around ourselves. So please join in welcoming Kurt Dannwolf from ODP Architects, and he will tackle right this topic.
Thank you. Thank you for having me, everyone. It's really great to be here. I'm Kurt Dannwolf. I'm one of the founding partners of O'Donnell, Dannwolf and Partners Architects. It's really great to be in this room today. This building is what brought me to South Florida. In 1998, I worked for Handel Architects in New York City. I was the lead designer on this building for Millennium Partners, the developer. In late 1999, I was asked to go to Miami to work alongside the local architect during the CA phase. I wound up staying the next 3 years. I got married to a Cuban woman. Can't really take her much out of Miami. I got all the way to Broward County. Started the firm ODP in 2003 with my business partner, Ed O'Donnell. Prior to working at Handel, I worked at KPF for 6 years and also in New York. There, the firm had the role of playing designer with an array of local architects from all over the world, assisting with the projects. I got to work on some amazing projects, 3 in various cities in China, a telecom company in Buenos Aires headquarters, a building in Seoul, Korea, and the ultra-exotic city of Cleveland, Ohio. All with the help of an AOR firm working beside us. So basically, I spent the first 12 years of my career working with an AOR as a designer. I thought it was how things had normally worked in the industry. So the first 2 of these, I would consider the minimum expectation for an AOR role. Assisting with navigating local zoning, local building codes, that's the minimum. But this isn't really the full scope of what an AOR should be doing to help make the project a success. This area of quality assurance and respecting the design intent over there, I would separate the great projects from the passable. For a project to be successful, the AOR role needs to involve much more than the designer merely handing off a set of documents somewhere in the design development stage and disappearing or being pushed off the project until the project's grand opening. The best projects involve the AOR getting involved early in the design process and the design architect staying involved in some capacity all the way through. It is our experience the design architect team and the AOR team should be working together as one unit by the middle of schematic design at the latest, and in concept is better. Often when we start AOR work, we have several meetings and conversations with the designers to understand what is important to them and what is important to ownership. Often, we stress early on that we are here to assist in bringing their vision to life. We come up with the strategies for dissecting the design into parts of each office can approach simultaneously to complement each other's efforts. This initial work split typically is done around the back of house spaces and required here in South Florida that may be unique and core layouts with the designers focusing on the exterior design. If the AOR is involved in concept, there's a much better chance that it will be laid out correctly very early so there's not rework later on, as might happen if the AOR comes on later in the ZD design stage. There should be a steady flow of group chats and Zoom meetings weekly for the designer and AOR to be in constant communication. This is a good sign that the collaboration is working effectively. A sure sign something is wrong is when there is very little interplay between the design team and the AOR team. A general note should be that the AOR's role is not to reinterpret the designer's design or create other design options and show them to ownership. This is another sure sign that the project is not going to go its best and just creates tension between the architect teams when they should be working as one unit. Also, an important consideration that the AOR will assist with is filling the role of local consultant teams. A lot of times the designers will have favorites that they want to bring along as they have worked in the past on several projects, and it seems familiar to and just easier. However, South Florida is a very different market within the rest of the country and most of the rest of the world. Structural engineers need to have a deep understanding of lateral systems for our hurricane season winds, and MEP engineers need to know how to deal with our humid environment. And what might be an almost yearly amount of rainfall in their hometown happens in just one afternoon on a June day. It is a mistake to not discuss this and explain this all to the parties who haven't worked in South Florida prior to giving the importance to this. Another important consideration the AOR can assist all out-of-town parties with is the explanation of how the dreaded 558 claims that typically come with a condo project, and work what to do is best to prepare and minimize, if not totally avoid them. Understandably, the out-of-town designers and developers will typically want to bring the giant spec book with them. Florida doesn't do this. This is usually a conversation that comes back around for several months on the project, as no one from outside of Florida has heard of designing a building without a spec book. So who is ODP, and why do we do AOR work? ODP is a full-service architectural firm with offices in Hollywood, Fort Lauderdale, Tampa, and Naples. We have 138 employees. I like to keep the split between in-house work and AOR work around 50-50. It's currently 55 to the AOR and 45 to our own. We have been doing AOR work since 2011. So why do we take on any AOR work? The short answer is we were asked by the developers of 1000 Museum to do a zoning analysis for that site. They were very upfront saying they were thinking of using an international design firm for the design. I said that's fine, we would still help with the zoning for the next project. We then somehow started taking calls from Zaha Hadid Architects about concept and how South Florida construction works. The basics of an AOR role. After a month of back and forth, they asked us if we would consider being in the AOR. It didn't seem like a very good idea to say no to a Pritzker Prize winning firm, so we started down the road of AOR work. We got fairly good at it, and we started taking more calls for AOR work, many from international designers looking for a local partner on a project they wanted to be proactive in selecting their working partner. That's happened with Foster & Partners when we were asked to be their partner in the flagship Apple store in Aventura Mall. Having spent the first 12 years on the other side as a designer, I could draw on those experiences to guide our team in making a successful project. Being able to see the project and process from the design side is helpful in understanding where they are coming from and seeing how solutions to issues can be had. Some other benefits become clear after we started working as the AOR, which were not readily apparent 12 years prior, due to the world having gotten much more connected. For example, since the design firms are typically global players, they have relationships with subcontractors and vendors from all over the world. When they partner with them, we get to trade vendors. On 1000 Museum, Zaha had worked previously with a GFRC supplier on a project in Egypt that wound up not happening, but they were perfect for our project and were used to left-in-place formwork. On a Foster project, they introduced us to a metal fabricator from Mexico that had done a project in Mexico City with. All these firms use Rhino CNC programs, which our office tries to exploit to its fullest. It basically lets you take a 3D file and send it directly to a milling machine. This is something that wasn't possible when I was working for the firms in New York a decade ago. So I thought the rest of this, I would go through some photos of two projects that we have done AOR work for. One's still in the process. It's actually an office building in Aventura, and the other one's the well-known 1000 Museum. So these are some of the partners that we've had over the years. Not everybody, but we've worked with all these firms. This is what we're working on, some of the stuff we're working on currently. And then this is just quickly how the responsibility matrix may look in terms of the AOR role. Sometimes this is typically the structure of the contracts if the owner is from out of town, where we're all being held by the owner individually. And then this is the structure typical of South Florida developers, where we hold everybody's contract and they hold ours as an umbrella. Typically, the handoff for the drawings happens somewhere in the DD phase, but like I stated before, we'd like to be involved from the get-go with the design architect, following through all the way through CA. And this is just how all the pieces come together. So this is a partnership we have with Foster. It's ongoing. It's at 3050 Aventura Boulevard. So this is the vision that Foster created for the job. It's an office building with a 3-story parking garage underneath a tiny little site. And this is our steel model. So what's interesting about this in Florida, it's actually a steel framed building. We don't get to do too many of those. The erectors are actually coming in from Atlanta to do this. Our firm models all the openings in the steel, along with the TT, who is the structural engineer on the job. Some of the diagrams that we put together for the steel. The building is an inverted pyramid, so that the steel is placed in space and using 3D coordinates. And it has one of the deeper basements we've worked on. It's 3 stories. So the points, our firm models all of the column covers, which are out of stainless steel. All the numbers represent points on a grid that we then map to a matrix that then gets used for assembly. And then some of the cladding connections. So we work through all this with Parmastalisa, who is the fabricator on this, and TT, the structural engineer. At this point, Foster & Partners is working on the interiors of the job, and we're putting all the fabrication drawings together. And this is part of the construction photos ongoing now. That's the outline of the 3 stories of basement, with the pile caps going in below. So since it's a steel building, the core went first. So the core is actually finished. You can see it off of Biscayne Boulevard. And the photo on the left is the 3 stories of basement being finished off. The yellow lines represent where the steel is going to be eventually. And this is the 1000 Museum. This is the one on Biscayne Boulevard. So that's their vision. That was the first photo they showed the developers. At the time, no one quite knew how we were going to build it. One of the first solutions was to try and cast the concrete shapes. This is some of the first experiments we had the GC do in terms of pouring concrete into the forms that they wanted on the job. And then what actually happened was we used left-in-place formwork. So our firm modeled all of the rebar and panel drawings to make sure there was no rebar clashes between the concrete frame and the left in place formwork on the project. There's 8,800 individual pieces that got shipped from Dubai and lifted into place. This is the model that we did in-house to figure out all the pieces. This is a vision of the pool deck and how the columns were supposed to come down into it. That's them forming all of it. And then one of the challenges on this job was to how to map all the curves and give that to the contractor in a way that could be readily formed and put in place. So a series of diagrams and drawings were done for all the various curves. And we wrote script files in Rhino for all those points. There's a plan represents a point in space in X, Y, and Z every 6 inches for every curve, which then was surveyed onto this formwork on the site. And that's the finished product. All the pieces of the tower from this point up were left in place formwork, meaning that the columns had GFRC pieces on 2 sides that were put together with proprietary, basically the shipping strap, and let concrete and rebar dumped into them, and then let it set, and then pull the straps off, and the concrete forms stay for the finish. This is them putting some of that together, the top of the building. And last, this is the vision of the pool at the very top. Our firm did all the drawings for how that GFRC ceiling was supposed to go together and hide all the mechanical and plumbing and fire protection systems behind it. And again, had to write script files to deal with all of the curves and how they were placed in space. And that's them forming the pool up with the panels in place. And that's it finished. So from vision to construction to finished product, it looks like the first renderings we did. And when we partner with these firms, that's what we try and bring, is their vision brought to life. So this is some of the stuff that we're working on right now. This is our own design. Quickly go through it, and thank you.
Thank you very much, Dan. That was great, Kurt. That was wonderful.
Thank you.
So we see that the AOR is very often the adult in the room, making life easy on all the parties involved. So our next presentation will take us a little bit deeper into the technical aspects of the curtain wall and the building envelope. We all know, especially in markets like in Florida, that the general principle is design your best, silicone will do the rest. And the two friends that we have here today, John Medina and Maria Moral, will take us deeper into this concept of making sure that we are building in compliance with the codes here locally. So join in welcoming both of them, John and Maria.
Hello, everyone. Good morning, everyone. I hope you guys are all awake by now. First of all, I want to thank Susan and World of Façades for this wonderful invitation. It's an honor to be here with you guys today. My name is Maria Moral. I am an architect and partner at Miami Curtain Wall Consultants. And this is John Medina, founding partner and principal of the firm. We want to talk to you guys a little bit today about the architectural skin before and after Champlain, but in reality, this is more of a retrospective of the last 50 years of history for the architectural skin in South Florida. So basically is what lurks under the waters.
Good morning, everybody. Preparing for this presentation, I was often reminded of my thoughts in this culture that we live in that is so diverse. And I wanted to sort of incorporate the notion of sofrito. Sofrito, for those of you that come to work in South Florida, you learn very quickly that we have wonderful cuisine. And everybody somewhat likes Versailles, La Carreta, the places like that where that food is always served. And you have to get accustomed to the language. I've organized a series of thoughts, and I've had a first row seat in the development of glazing in Florida that pretty much has transformed the skyline over the last 50 years. I'm actually as close to a native as possible. Came here when I was about 6 years old, and I've gone through all the major Category 5 storms and hurricanes. And so I've seen the evolution of the window into the curtain wall. And that's what we're going to talk about. In about 20 minutes, we're going to go through 4 acts, 2 intermissions of a glazing opera. It may sound a little odd, but it has been kind of like a wonderful show as to how this skyline has developed. This diagram, and I'm going to call it a diagram, is it's sort of it's somewhat contorted, but it basically establishes the directionality and the intensity of South Florida over the last 50 years. It's a sort of a hybrid or Frankenstein that's this combination of a Richter magnitude scale kind of lie detector, an electrocardiogram, and stock market trends. They outline a metamorphosis, and I'm going to start this with, in 20 minutes, I'm going to get so much in, and I'm probably going to miss half of what I wrote. So I'll just start with the four stages. Stage left is this pioneer city, so that sort of pretty much evolved. I tell you that it was a low-rise town from the 50s to about the 70s, spotted with certain buildings that were iconic. The buildings were mostly mass and punched windows. And for the most part, people that lived here didn't have air conditioning, and they were acclimated. People got acclimated, and it was all right to perspire, sweat, and people got wet, and that was okay. And the psychology of people was hurricanes destroy things, and little glass is good. Lots of walls are safe. No? Ventilation mattered. There was a technology that dealt with how do you clean your windows if you're in a tall place. Double-hung windows were kind of designed for ventilation and for cleaning them. And that was important. Type of glass was single-strength glass, double-strength glass. You could still see some of that glass today in the older buildings. You go some places in Hialeah, and they're still there. You had the jalousie windows, the awning windows, which the glass wasn't laminated. And remarkably, they would hold up during Category 4 and Category 5 hurricanes. Test laboratory. One of the few test laboratories in Florida was, in the United States, was right here in Medley, Florida. It was Construction Research Laboratory. That was one of the developments that started in the 50s. And Zak, not our Zak, but A.A. Saknowski was a pioneer in glazing and actually did a lot of the early development work on the machines that made the testing that we are so commonly involved in laboratories and in the field. The second act of ours, and that very first act, I'm going to call it la quinceañera. the debutante, no? The prepubescent kind of city, which when you look at the code, it says that the modern city developed here in the 1970s. So that's kind of the Florida building code, the strongest code in the country, basically says the modern city here starts in the 1970s. The second act, I'm going to call it, I called it Havana Nights. Miami Vice was a thing. Some of you may not have seen that show, but every week we were graced by Arquitectónica's 3 monumental buildings that made a difference in how we looked at architecture here, which is the Imperial, the Atlantis, and the Palace. Geometries of building became sleeker, not as small, short, and I would say dumpy. All of a sudden there was some style. Sweating in discos wasn't cool. I could tell you from experience. I would tell you that was the adolescence. That was sort of the burgeoning of what was happening in this city. And the world was looking at us because everybody was watching Miami Vice along with the locals. Right? The bullet points of this second phase, and I'm going to use my pointer, is right here, was wind was evil, and people were concerned about glass and how glass was going to make out. And people were concerned psychologically if the glass was going to break. And so these early trendsetter buildings by Fort Brazier and the guys at Arquitectónica and Liz, they were how much glass could you put on a building where you could sell it to the public? Air conditioning in that stage was desired and now available. Great motivator. More glass and less masonry. The public wanted more sunlight, fenestration, and less mass walls. Less concern for natural ventilation, and window washing is not as important. Stick system window walls with awnings, single hung windows became something in taller buildings, emerging of the new stick system and the kind of older technologies of glazing. And in this phase, we hit a bump, which is Hurricane Andrew. And Hurricane Andrew does the industry a great favor. It causes us to look forward. The third act was Que Pasa USA. Some of you may not know that term, but that was an iconic period in South Florida where people understood that if you weren't speaking Spanish, that there was some sort of problem. So if you didn't know what sofrito was, you weren't going to get that Cuban meal. So notables like right after Hurricane Andrew, and Hurricane Andrew was in 92, to the 24th of August 24th, 1992, about a year later, SAC, not our SAC, A.A. Saknowski, and a fellow named Joseph Miner were instrumental in sort of inventing the projector. And the projector is not the projector that we're used to. We're talking about the cannon that shoots the 2x4 and did the cycling. There were many people involved in that time. The destruction of certain places was pretty intense, and something had to be considered differently, which is how much could glass do? And that was a concern. Most of the operable windows became obsolete because they couldn't stand up to impact testing and cycling. It's almost a relic nowadays to find awning windows. The old Florida rooms used to have awning windows and jalousie windows. And jalousie windows was just a solid piece of glass stacked with one another if you hadn't seen them. And they would do fine during Category 5 hurricanes. They are no longer around. So if you find one, maybe you hang it on the wall and it becomes a piece of art. Impact glass takes over, where storm shutters was the notion, and how to protect your building from impact. And Rolladin is no longer around. And the final act, Despacito, build back better, right? certain things happen in this stage, which is the one we're at now. And what's interesting of it is water is evil and wasted energy is evil. All right. Originally, over here, wind was evil. The world turned towards us at another intermission that I'm going to call it an intermission, and another body blow, which was a Champlain Tower. And suddenly the world looked at water in a different way. Water suddenly is very bad. And lawyers truly appreciate that concept. So the first heart attack, Hurricane Andrew, was the first intermission seismic event that caused the interest of the world to tune in and see us again. Miami Vice came first, Hurricane Andrew came second. People enjoy blood and guts. Our city was devastated. It caused us to reinvent the code, and the code today is the strongest because of simply TAS 201, 202, 203, which is in the high hazard wind zone of the Florida Building Code. The second heart attack, and it was a terrible body blow with Champlain Tower, and that's forced us to look at how we recertify the older buildings that we have to retrofit with new technology. And the sophistication of utilizing old buildings with new technology or new technology with old buildings is very, very difficult to do. And it's one of the things that we are now tasked as consultants and architects.
So here we have a few examples of this 4 different stages or 4 acts of the evolution of the curtain wall or the glazing in South Florida and in the world, really. These are 4 projects that we have been involved with, and they basically represent some way, to some level, each one of those stages. The first one, we see a lot of mass, punched windows, very small punched windows. In this project, we were the architects of record and the glazing consultants, and we just replaced those non-balcony windows for insulated laminated systems. The second one is the Hamilton. This is a building in Miami. It was built in 1984. And here we see more glass. We still see a lot of mass, but we see more glass. And these are window wall systems. Here we, again, were the architects of record, and we replaced all of the glazing systems in this building. On the third one, we see La Gorge Palace Condominium. Now, this building was built in 1995. We're currently working here, and we see the curtain wall, the stick system, there at this time. We are, like I said, in the design process at this moment, but this is a 4-sided adhere stick system, and we are proposing to do a insulated laminated system, so we really have to look at the anchors and how that load transfers into those existing anchors. And the last example is Brickell Arch, also known as Espiritu Santo, just few blocks down. This building, we were the consultants, the glazing consultants for, and it was completed in 2005. This system is a rain screen pressure equalized curtain wall system. It had an insulated glass with a sacrificial light on the exterior. And also, in this case, we had the opportunity to do some testing. We invented a machine where we tested the half-in anchors to make sure that they would take the impact of the surge at the lower levels. So these are 4 of that transition that John was talking about.
And I just sort of chime in on the fluff and talk about, again, sofrito. We are here back at 4 stages. First stage, which is that debutante stage. You can kind of see the blocky building, punched windows. And it gives you kind of an idea of when I used to be a kid and go to school dances at the McAllister, right on Biscayne Boulevard. And some of you don't know of that building because it was torn down for the building right over here. And so you can see a transformation going on from one screen to another, where the first buildings were sort of short and stocky, punched windows. The first series of windows, buildings with stick systems, starts to be introduced. The AmeriFirst building, you could kind of see some of the buildings that are a little shorter. Let me see. The federal courthouse is in the first image. In the second image, over here, you're seeing the AmeriFirst and the DuPont Plaza back over here. That's not there anymore. Many of these buildings over time, their technology was changed out, and newer windows were introduced, but the growth has continued, and you can kind of see in stage 3. And stage 3 is where the high-rises have become skyscrapers. There's that burgeoning skyscraper in the Southeast Financial Center and the Centrust building, which are right over there. And those buildings, those buildings start to become very lean, very tall, and high-rise. The current stage that we're in is this one, where the Skyline is completely transformed, and 2 and 3 skyscrapers or high-rises, 50 to 60-story high-rises, are going up at a time, not only in Miami, but Fort Lauderdale, West Palm, all the way along the coast.
So, mock-up testing and laboratories, a little bit of the evolution of that as well. Prior to Andrew, back in the 1950s, there were certain labs that started doing mock-up testings. These mock-up testings were done more for the intention of product development. And they were based mainly on the project manuals and consultants' recommendations. There were 3 main labs in the country that would emphasize this type of testing: the Construction Research Lab in Medley, Florida, Jack Stevens in Houston, Texas, and ATI in York, Pennsylvania. I'm talking back late 50s, 60s, 70s. So the emphasis was more on that product development. Some of the tests that would be performed were air, water, dynamic, structural, design load, etc. Now, dynamic test, that was the really cool test that was performed with airplane engines. These 3 labs had those airplane engines. John was a testing engineer at the Medley laboratory, and he performed all of these tests that I'm putting on the screen. This is an example of that airplane engine and that test taking place. That test was really cool because it would simulate the effects of a hurricane. The rain, basically, the water will run upwards during that simulation. Again, still before 1992, before Andrew, this is another test that would be performed, which is an air infiltration and a water infiltration test on the right-hand side that you can see there. Now, Andrew happens, and NOAs become a thing, and at this moment, the law changes. So the testing application standards are introduced, and there are specific procedures that now have to meet the Florida building codes. So these same tests were combined with the cyclic and impact tests that John mentioned a little bit earlier. Today's emphasis is more on getting these products approved for NOAs and not so much on product development, at least for this many labs that we have in the area at this moment. The dynamic test is not part of this requirements of this battery of tests that need to be done at this moment.
Hurricane Andrew obviously set the tone for all the changes to the Florida code that associated themselves with wind and water and impact. That's me as a young man in Homestead, where the city was demolished. We learned from this that we had to prepare for how greater density was going to affect the city with tall buildings. And so we took into account, in Miami-Dade County, we took into account how to go through a code change or a series of code changes that brings us to today.
Okay, so Hilma hits 2005, and this is the first time that Miami is really put to the test for high rises. Here we see this is 1221, the Greenberg Torek Tower, just 2 blocks down. It got heavily impacted. This was a stick system, structurally adhered glass, tempered glass at the time. So this was a 27-story tower that lost more than 30% of the glass, and more than 70% of the glass was on the east side facade at the time. We saw all of those units, all of those offices were destroyed, were completely destroyed. It took 9 months, approximately, to secure the face of this building, the skin of this building, so the space would be habitable again. It took $8 million to repair the exteriors, not taking into account business interruption, which was massive in that case. Now, across from that building and across from us now, we see the Espiritu Santo, what used to be the Espiritu Santo. The effects on this tower were also devastating. There was an avalanche of glass that would continue to break, but the interiors in this building were basically not affected. They continued to be able to function in a relatively fast time. This is a 505-foot tall tower, which was completed just several months. It was hit. It took 3 years and approximately $47 million to restore this building, but they were able to come back within 3 days, approximately. And John was responsible to give the order to open both of these buildings. We have to finish.
Keep going. These are some of the examples of this, the third act, melting pot, glass, mostly glass, little wall, as much visual contact with the outside without going outside and getting wet or perspiring. I think that the stick system has pretty much, for storefronts are utilized, but the unitized curtain wall and window wall is the way of the future. And so the examples here are all buildings that we've worked on as consultants. The Flatiron, the Bentley is in the drawing boards. The 600 we're involved in, Grove at Grand Bay. The impact of Champlain Tower was a body blow to Miami. All of a sudden, it's not everything is great. Not everything is great in the construction world. Sometimes in this specific project, when it collapsed, we lost friends. As a result of this project and me having been involved as a consultant, we discovered that for the most part, how to retrofit, how to rehabilitate a building became a priority. But in addition to that, how to deal with sustainability issues of energy conservation and introducing thermal bridging concepts that are associated to ASHRAE 90.1 and air infiltration became very important. How to control air infiltration in the building and containing that energy in such a way that the waste of resources isn't going out the door because of leaky gasketing.
These are just general studies that were done in a class that John had, a studio at the University of Miami back in 1991, taking into consideration what happens. That's again the 1221 right here, and that is the study of what happens if it gets hit by waves, if we get hit in that case. So I know that tidal waves and seawater rise is a concern in the world internationally. So he was looking at this with his students more than 3 decades ago. This is another example of those studies. And now we get here.
And so now we're here at the in the fourth phase or stage of our growth. And now the most important aspect is to bring glazing technology into the older buildings that are going to remain historic, as well as taking into account the 558 claim and the 558 claim on steroids that circles us all the time as we're building buildings. And so there are positive aspects of that. And as I see it, it's a needed aspect to determine how to improve things in the future of newer buildings. I'll end with what lurks within and under the malignant water. Well, first of all, that's my daughter up there catching the shark, all right? So I'm just gonna point that out. And I'm gonna say state and federal regulations have aligned with FEMA regulations, 558 ordinance, ASTRE 90.1, and enhancements to the Florida Building Code now appears to apply to both the first 3 acts of the last act of our opera. All glass and little mass walls has become the future of new buildings, but equally important, the retrofit and the rehabilitation of the older buildings.
Thank you so much, everyone.
Thank you very, very much, guys. John and Maria, that was a very, very interesting journey into the whole development of the impact rating. And thank you also very much for bringing up Zak's name. I remember back then I was living in Europe, and we were kind of looking up towards the American impact testing as being the most advanced. And today, if you go to that lab, you think to yourself, really? Was that what it was? He was certainly a legend. Thank you very much. That was a very, very interesting, long, but very interesting presentation. Now, the next topic actually is very interesting, and that is the topic of podiums. We all see that we are building these magnificent buildings, and we have always to deal with what do we do at the podium level with the flooding aspects. It's a very unique Florida topic, and we have 2 great engineers to talk to us about this. One is Ahmad, who a lot of you know from his previous engagement in his family and his own business right now. And then Anshuman Dogra from Stantec. So they will walk us through the problematic and the solutions of podiums in buildings here in South Florida. Join in welcoming both of these gentlemen up here on stage.
Thank you. Thank you.
Welcome.
How are you? Good morning, everybody. My name is Ahmad. I'm the founder and CEO of Ahmad PE Inc., also known as JAPE. We specialize in design and development of facade structures, and I've been practicing in this field for 25 years. And I'm here with my colleague Anshuman. He'll be talking about himself and the topic for today.
Good morning, everyone. My name is Anshuman. I'm a structural engineer at Stantec, and today we are here to discuss some non-traditional ways of protecting your facade and your glazing system at the podium level.
So before we get into the non-traditional ways, I want to quickly brush over the traditional methods of designing facades in the high-velocity hurricane zone, which is primarily considered to be in South Florida. In order to do that, the overview of this is to start off with regulatory compliance, making sure we meet all the codes and standards. We do the risk assessment by doing all the engineering calculations, select the right materials, make sure the system can be designed to transfer loads to the substrates, and then we get into the testing and certification, which in this case, for a product to be installed in the Florida market, has to be tested and approved, and has to have either a Florida product approval or a Miami-Dade County NOA. Now, transitioning from into a different topic, we're going to talk about designing facades to meet flood requirements. So being in a high velocity zone, we get hurricanes that that can cause heavy rainfall, inland water flow. And in order to mitigate that, we need to make sure that our systems are either elevated above the ground or design a flood-resistant system using flood-resistant materials.
All right, so let's discuss the load cases, the flood load cases that the code says we need to design for. So broadly speaking, there are 5 load cases. You have hydrostatic load, which is a typical water column against the glazing, as shown in this picture from Hurricane Ian in Fort Myers area. Hydrodynamic is a moving water with flood velocity that causes dynamic loads on your glazing system or your facade. Wave load, as the name indicates, these are the waves slamming or smashing against your glazing systems. Buoyancy forces are the uplift forces caused by water that's trying to come up. And debris impact is any impact from floating debris that's floating with the flood waters. So before discussing the flood design, let's discuss some pitfalls. So as EOR, we review a lot of submissions from glazing consultants. And one thing that I commonly see is that they calculate the hydrostatic load based on the base flood elevation. And then they find a product in the market that works for that hydrostatic head. So for example, if they calculate 5 foot of flood water, they find a system that works for 5 foot. However, what the code says is that there's also a dynamic component, and you have to convert that dynamic component into equivalent hydrostatic, meaning that a system that is designed for 5 foot of flood water may not work in reality because the actual load is a little bit more because of the hydrodynamic loads.
So one of the methods for seeking certifications is FM Global approvals. This approval process requires like a certain performance criteria, which is to make sure that the system can withstand water infiltration under specific load conditions, making sure that it's structurally integral in transferring and resisting hydrodynamic forces, and durable to withstand long-term flood loads. This is important because it provides confidence to the stakeholders, such as insurance companies, owners, to know that the products being used can perform in these flood conditions.
All right, so before testing, we always start with engineering because it's cheaper and faster. So we go through several possible combinations of glass, and we zero down on possible compositions that may work for the flood load. So this is an example of a recent project that we did for one of our clients, where we were developing some glass compositions to work with the flood loads. We chose 2 glass compositions at the end. The only difference is that the glass composition 1 had a 3/8-inch tempered glass, and the composition 2 has a 1/2-inch tempered glass. Both these compositions have a 0.090 SGP interlayer and a 1/4-inch outer sacrificial tempered glass. So as you can see from the results here, we started with a 66-inch water column, and on the very top, you can see the maximum stress that a tempered glass can handle is 11,970 psi. So you can see that the sacrificial light cracked under a 66-inch water column for both the compositions. Then we reduced the water column to 36 inches. Everything worked. We brought it back to 66 inches, but we then removed the sacrificial light, and everything worked again. So we continued throwing more and more challenges at it. We broke one light deliberately to see if it fails, and the glass composition still worked. And ultimately, we impacted the glass composition with 600 joules of impact energy. And as you can see, composition 1 failed, but composition 2 was very, very close to the maximum prescribed limit.
So we wanted to put that into an example for a product that we worked on. We partnered with one of our clients, Crawford Tracy Corporation, and we engineered their Protec 7 and their Protec 9 structurally glazed unitized curtainwall system. And as Anshuman mentioned, the glass composition is shown here. We were able to achieve a water rating of 100 PSF, as well as for the flood ratings, we were able to achieve for Protec 7 a water height of 4 feet, and then for the Protec 9 a water height of 7 feet. So this makes the system quite unique in the marketplace because not only is rated for high velocity hurricane zone winds, and it's also rated for floods as well. So now changing topics a little bit, we're going to get into security glazing. Security glazing is essential for protection against forced entry, ballistic threats, and other security risks. Some of the applications for this, for the use of this is prisons, government buildings, embassies, essential facilities, and so on.
So before going into the design process, let's discuss the differences in the design of standard glass versus a security glass. So as we have already seen, standard glass is designed for dead loads, wind loads, debris impact, water infiltration. For security glazing, you need to design the glass for impact resistance, bullet resistance, blast resistance, forced entry, and fire resistance. These are the commonly available testing standards. So for ballistic resistance, you have the 4 standards listed here. The HP White and WMFL are the 2 most important in that. For standard for detention facilities, you have ASTM F1915. For thermal, you have these 2 ASTM documents. And for forced entry, you have 1233. So talking about these standards a little bit, HP White standard is essentially what it is you shoot bullets at different velocities and angles at your glazing system, and then you observe the performance. For ASTM F1233, as the picture shows, it's basically a sequence of impacts on your glazing system in a lab setting. So, for example, the levels of safety here, defined by the ASTM standard, are level 1, 2, 3. 1 is to resist attacks by handheld tools. 2 is to resist attacks by power tools. And then 3rd is for sustained and concentrated attacks. And then you have the thermal tests, which are done by UL 9, 10B, and 10C. Essentially what these are the protocols to test windows, doors, and hardware for fire resistance. All right, so talking about the performance grades for security glazing. There are 4 grade numbers, 1 to 4, which are associated with a static load and impact energy. So for example, let's say if you're designing for security grade 4, you have to design your glass for 11,000 pounds of static load and 100 joules of energy at locks, 35 joules of energy at hinges, and then 100 joules at glazing. Also, there are impact tests and there are security grades associated with that. So you have security grade 1 to 4. And as you can see, what you basically do is you design your systems for a sequence of events. So here, for example, if you're designing for security grade 4, you start with a blunt impactor, you do 25 impacts, followed by 50 impacts of sharp impactor, and then back to 25 more impacts of blunt impactor. So that basically is the design standard for security glazing for forced entry. HP White, again, just wanted to highlight that it also has different levels of security. So you have level 1 to 5. The last row summarizes the difference essentially. So you have level 1 designed only for 5 sequences of forced entry, whereas you have a level 5 designed for 54 sequences. These are the tools that can be used for forced entry, like sledgehammer, ram, pinch bar, chisel, and all these items listed here. Essentially, you just have to design them for the correct or corresponding sequences. And this is the last protocol that we discussed for forced entry, which is the hardest and the toughest to design for. This is the WMFL procedure for riot simulation. Why it's so hard is because the duration of your attack is now 60 minutes. So you have to sustain or design for a concentrated attack that lasts 60 minutes. The difference between level 1 and level 2 is that 1 is rated for ballistic also, whereas 2 is not rated for ballistic, but it's rated for everything else, like claw hammer, sledgehammer. And as you can see, you have to do 5 minutes of impact using each tool, and the total attack lasts 60 minutes. Level 3 is a lesser level of safety. It only lasts for 30 minutes.
So we did a case study for a project in New York, and we partnered with one of our clients, Optimum Windows. They're out here today. Please check them out. They have really great products. And we ended up designing their system to be to transfer the loads to the frame without using any mechanical fasteners and using structural sealants. And the glass composition that we have is shown here is a combination of 1/4-inch tempered glass with argon airspace, 1/4-inch polycarbonate sheets, 3/16 glass. And this glass composition gave us a level 1 forced entry and a level 4 security grade per ASTM 1915. And Anshuman just mentioned, this allowed us to get a resistance of 50 sledgehammer impacts, pickaxe 50 impacts, thermal conditioning, as well as torch. And also to note that we considered the energy performance in the design of the glass, so we were able to get a really high U factor and solar heat gain coefficients. Now, transitioning into a different topic, we wanted to talk about designing glass for anti-terrorism subject to air blast loadings. This falls under the standard of ASTM F1642. Is primarily designed to reduce risk of personal injury and facility damage. So there's 5 different hazard levels that we have here. Type 1 being low risk for minimal protection. Level 2 for moderate risk for like public buildings. Level 3 for high risk, such as military buildings or critical infrastructures. And level 4 being extreme risks, such as nuclear power plants or command centers.
All right, so before we discuss the next slides, we just want to mention that we are going to discuss a project. It was a project that we did in Middle East for the United States Air Force. That's all we can talk about because of the confidentiality agreements. But we are going to highlight some aspects of the design for the facade. So here you can see that there are 2 ways to design your glazing system or your facade for anti-terrorism. You have the traditional design analysis, which is subdivided into computational design and dynamic design. The dynamic design is essentially it's a simulation of air blast loading using complex software. Computational design analysis is your typical engineering that we do regularly, calculations and simulations. Basically, it establishes a deflection criterion, and then you have to calculate the loads and also make sure that it complies with some ASTM documents. For the project that I just mentioned, we had an explosive weight category 2, which is 25 kilograms of TNT, and the standoff distance was 65 foot. Then you have testing by 2 methods. One is arena and one is shock tube. Arena test is basically a field test where actual explosive devices are detonated and the air blast loading is created using the actual blast. A shock tube is a lab setting where the glazing systems are impacted using air blast, for air blast loading using a shock tube. So when we started working on the project, since we do wind engineering commonly, we are very comfortable with that. We had to find a way to convert this air blast loading into something that we are very comfortable with, and that is so this code, UFC code, it helps us to convert air blast loading into equivalent wind load. As you can see from the chart on the right, we were given 65-foot standoff and 25 kilograms of TNT. Using the chart, it translated to 72 pounds per square foot 3-second wind energy force or pressure.
So the glazing composition, again, for this project was insulated laminated glass, which was a combination of heat-strengthened glass, reflective film, argon space, low E-coated glass, again, to enhance energy performance, and then having a polycarbonate sheets with heat-strengthened glass. So that gave us a total thickness for this, to qualify this glass, was 1.25 inches, which is about 32 millimeters. And again, we were able to maintain a high performing for solar heat gain and low E-coatings.
All right, so moving on to the next slides, we discussed the engineering. Now let's see how these glazing compositions perform under testing. So starting with this test done by Curare on different glass types, different interlays and different interlay thicknesses. As you can see on the very last column, you have the performance condition. 3A basically means that your glass is allowed to shatter and the pieces should not fall more than 1 meter away from the glazing system. Condition 2 is your glass is allowed to shatter, but the pieces should not come out of the glazing system at all. Now, if you can see that there are some commonly used interlays listed there. You have PVB, you have sentry glass. All these interlays perform satisfactorily against the air blast loading in shock tube. And you can see that they achieved a performance condition rating from 2 to 3A. Then let's see how these glazing systems perform in an actual arena test, which is a real-time simulation of air blast loading in an open field setting. This test was done again at this facility in Texas, and you can see some commonly you can see some of the common names in the list, like Crawford Tracy, ES Windows, PGT, YKK. The commonly available systems from these manufacturers was chosen and subjected to air blast loading. You can see the blast level was quite high. It was 6 psi. And almost all the systems performed satisfactorily, but some of them achieved a very high level of protection per UFC, meaning that to design for air blast loading or anti-terrorism design, we don't have to redesign or let's say re-engineer something. The commonly available systems can be tweaked to meet the air blast loading requirements for anti-terrorism design. So this slide is just to discuss, can the envelope be pushed even further, right? So this test was done by SAF Glass on their interlayer SAF Glass, which is a polycarbonate interlayer. And as you can see here, we were talking about 65 foot of standoff, 25 kilograms of TNT. But what happens if the standoff is like 7.5 feet or 15 feet? What if it's not TNT, it's a claymore mine or a hand grenade at 6 feet? So they did these tests for different threat levels. And as you can see, the polycarbonate interlayer performed well in all the cases. There were no through openings at all. And there was a spall in some of these cases, a low hazard spall, meaning that it corresponds to the 3A rating, that the fragments did not land more than 1 meter away from the glazing system.
So in conclusion, we talked about designing glazing and facades for floods, air blast, and security glazing. I just want to finish by saying that, with having access to cutting-edge technology and advanced testing methods, we are really able to design our systems using the right materials and really performing to a high level, which allows our buildings to be more resilient and meet the latest and highest code standards. I just want to end by saying that engineering is a power of innovation. Engineering isn't just a profession, it's a testament to human ingenuity and resilience.
Thanks.
Thank you.
Very good, thank you. Great presentation, guys. Such a dry and difficult topic to be presented that way is nice. It's very nice. So we are now diving a little bit more into products and especially glass. Then I would like to call Bob Ford of Eastman to come up here and talk to us about high performance PVB interlayers. Please welcome Bob Ford.
Thank you. Appreciate it. Thank you. Thank you, everybody. My name is Bob Ford, and I'm an account manager with Eastman Saflex. We manufacture Saflex brand and Vanceva brand PVB, and we're using these obviously in the South Florida market for hurricane protection. And what I want to do today is kind of take you through a little bit about kind of what we've been using those interlayers for over the last 20 years or so, and some trends that are driving new applications for these products. I've got about 78 slides, so I'll try to get through these in under 700 seconds. All right, so what I'm going to talk about again, kind of the history of where we've been. We had some really, really interesting presentations to start off the afternoon. Several of those products that they showed did have various hurricane PVB interlayers used in them. Some of the newer protective glazing trends, again, in South Florida, we're very focused obviously on the hurricane market, but security is becoming a bigger factor, and there's some new standards out there, particularly around active shooter for schools and other types of buildings, which we'll touch on, and kind of how the products that you're already using today translate into those new standards. And finally, we'll kind of have some, I don't know if this is really a question and answer session as I've had. We do have a booth outside, so you're welcome to stop by if we can assist with any questions you might have. So a little bit about Eastman. Some of the more mature faces in here might remember Eastman Kodak. That is the Eastman that we're a part of. We divested the Kodak business back a number of years ago. And when I started in the glass industry in 2001, Saflex and Vanceva were sold by a company called Solutia. And Eastman acquired Solutia back in 2012. So now we fall under the Eastman umbrella. In addition to some of the storm and safety products that we also have acoustic interlayers. Now, laminated glass using PVB already enhances the acoustic performance. It increases the STC and OITC numbers in a fenestration. But we do have an acoustic product that goes a little bit further. It's a tri-layer that disrupts more the octaves that are where human hearing is most sensitive, so provides an additional benefit from acoustic. Bird protection has been a really big topic at a lot of these architectural conferences over the last year or so. We do have a bird solution enhanced in the inner layer so that it's not a surface applied and it's not subjected to the elements, so it's protected within the glass itself. And obviously, structural and storm, which we deal more with here in South Florida, as well as our Van Sieva line of colors. All of Eastman's chemistry is PVB based. So basically what that means is any of our inner layers can be combined with others to gather those additional benefits of acoustic or sound, or color rather. So where are we now? Hurricane interlayers have been used in Florida ever since the codes changed after Hurricane Andrew. So for over 20 years, we've been using various interlayers, PVB, ionomers, glass-clad polycarbonates within protective glazing. What started obviously in Miami with the Miami building code evolved into how the Florida building code evolved, protecting openings in coastal areas based on their ultimate wind speeds. And this has spread through the southeastern, predominantly the southeastern United States, where we're seeing more and more of these hurricane impact products being used. Again, with the industry as a whole, there are several different types of interlayers out there. As was mentioned earlier, these products do need to go through a testing procedure. For the window side of it and the inner layer, it's impact and cycling testing to make sure it can resist, be it large missile glass, which is ground level to 30 feet, or small missile glass, which is above 30 feet. As I mentioned, we can combine these various PVB products and inner layers to create other benefits as well. The second bullet point I wanted to make a quick aside to, the years from COVID and beyond, we saw some serious supply chain disruption within the PVB industry. I know as many architects here, if you were coming out of projects then, you were probably seeing long lead times getting inner layers. And a little bit of history on that. As we came into COVID, a lot of manufacturers were thinking job sites are going to shut down, buildings going to slow, and there was a lot of emphasis toward probably de-inventorying and keeping as little cash and inventory as possible available. Well, obviously that didn't happen. Building continued to go. So in the process of trying to recover from that, we were hit with kind of a double whammy of a big freeze in Texas at a petrochemical plant in, I believe it was February of 2021, which a lot of the raw materials for both plasticizer and resin came out of petrochemicals, and that seriously impacted the industry, not just Eastman, but other companies as well. Container prices for getting stuff from overseas went from $4,000 a container to $20,000 a container. Getting material from one of our plants in Belgium to the US, what used to take 4 weeks started to take 12 to 14 weeks. So where I'm going is that we had a lot of disruption in our industry, but a lot of those supply chains have smoothed out now. So I think, I speak for myself, and I know Karari is here as well. I think I can say confidently that our supply chains have kind of come back now, as well as our raw material suppliers. We had, again, during that time, raw material folks declaring force majeure and a lot of things that were out of the actual manufacturer's control. So I think those things have settled out. So just a word of maybe confidence that, when specifying laminated glass, I do feel like our industry has recovered. So some of the trends we're talking about kind of going forward, we've seen a lot of the social unrest going on television. We've seen, unfortunately, although fortunately not as recently, but school shootings and the like that have started to happen in the US at a more frequent basis. And we've looked for different protective measures to kind of enhance some of those things that we already have. So we already have, there's standards, ASTM F1253 that deal with forced entry. We already use 60 gauge PVB for safety and security. We use 90 gauge for hurricane. And what we're seeing is that these products are now starting to move into other areas beside where they traditionally were. And this is the new standard that was recently developed by ASTM, 3561 for active shooter. This is basically a combination, and what it's trying to address is someone trying to gain entry into a building with a firearm and trying to break the glass open. This is not a bullet-resistant standard, that's important to note, but it's an enhanced force entry standard. And it's going to be similar to what we went through for the qualifying of products with this, with what we went through with the hurricane products. Okay, these have to be physically tested in a system. So glass interlayer framing, just like we do for either Dade County or Florida Building Code approved products. Essentially, it's going to give us some design flexibility. Again, some of the benefits of laminated glass inherently, they retain the glass shards after breaking, which protects the building envelope. This is the same technology and the same methodology for hurricane. You know, we have an automotive division. The windshield of your cars have PVB in the windshields to protect the driver from being ejected in an accident. So the whole idea of protecting these envelopes translates through this new standard. Again, it's a passive standard. It's, you know, laminated glass is going to be clear. You're adding low E coatings, you're still allowing visible light to come through, things like that, but we're not doing anything to obstruct or make the building look really any different than it would if it didn't have laminated glass inside of it. So again, the standard really is kind of approaching school design, okay? And, you know, within our public schools, I heard the statistic that 50% of the schools we have are at least 50 years old. And if you look at turning a building every 60 years or so, that means there's a fair amount of school construction that's going to need to be done in the coming years. One of our biggest growth areas right now within Eastman Interlayers is a customer that we have that produces a glass specifically for school retrofits using PVB interlayers, and that is where we're frankly seeing some of the largest growth is in these school retrofits. So you may see these start to come down the road at your own firms. I mentioned the 3561 standard, kind of the mindset and how this was created and the thought process going into it. We want to start with basically security glass, which would be 60 gauge PVB in most cases. We wanted to use commonly used both weapon and projectiles. So the regular force entry standards talk about multiple attacks with a ball peen hammer or a crowbar, often applying heat in the form of a blowtorch or cold in the form of a fire extinguisher. This standard uses an assault rifle to break the glass and then an impactor to basically test the hardiness of that weakened unit. Again, the same we do with hurricane. We hit the glass with a 9-pound 2x4, and then it goes through cycling once it's already been damaged. So we kind of had a bit of a roadmap on how to develop a standard like this, and it really came a lot from the hurricane market. So basically the system, again, it's a 10 shots with an assault weapon in the pattern that you see. And then if there's there's also 5 that will be applied to any kind of locking mechanism. So much like Florida or Miami Building Code, you're impacting not only the glass, but the framing system as well. And then after it's been weakened, it's then applied with an impactor. And what this does is there's 8 different standards or 8 different levels to this specification. And as you take the impactor and you subject the glass to more and more foot-pounds of energy, you move from level 1 all the way through level 8. And this is where, with what we've been doing already with hurricane, you know, we can give us a bit of a guideline of which of these standards to use. So out of the 8 levels, levels 1 and 2 would be considered like decent resistance. So that's probably going to be 30 gauge or 60 gauge PVB. And these are going to be a lot of the standard. If you're specifying laminated glass as a safety glazing, likely it's going to be 30 gauge PVB. If you're using, you know, forced entry or something like that right now, typically that's going to be 60 gauge PVB. So what you're using already for levels 1 and 2. As you get into levels 3 through 5, this would be more what you're used to looking at when we're talking level D large missile hurricane. So either a 90 gauge PVB, a 90 gauge ionomer, it could be glass-clad polycarbonate, it could be our 75 gauge Saflex Storm. These are the areas of a single interlayer, you know, that resist that 9-pound 2x4 from penetrating. And this would be typically give you the protection in levels 3 through 5 with these products. As we go through the higher levels, levels 6 through 8, these would typically be interlayers or combinations of interlayers that you're specifying for level E, or essential facilities. And typically what we do is we take that 2x4 and instead of shooting it at 50 feet per second, we shoot it at 80 feet per second. So it creates a much bigger impact to the glass. And typically that necessitates using a double layer or doubling up the thickness of the interlayer that you would use with normal large missile level D glazing. So by that same standard, you can do the same thing with levels 6 through 8. Typically it's going to be a 180 gauge PVB, it might be a double layer of an ionomer product or a Saflex Storm, something like that. So in summary, again, the ASTM new specification is something that we're all familiar with as far as the same products that you're already using. It will have to be a tested system, so it will require interlayer testing as well as a framing system. And we're kind of undergoing that. Ourselves and others in the industry are working with framing companies and window companies to start getting our products approved. We're basically able to give them a roadmap, if you will, of what type of glass that they can expect to be using for those different levels of protection. A lot of what's generating from what I've heard in the market from talking to customers, a lot of this is coming from either school districts, local municipalities, or even I've heard talk of in the state of Florida starting to mandate some of these products to be going into new school construction. So I think that's where a lot of this will come from. Again, a lot of what we use in laminated glass here in North America, they're often voluntary standards. So if you want to have a building that's bullet resistant or blast resistant or forced entry criteria, that's often a voluntary standard. Much like hurricane, there's a number of different ways to protect openings. Laminated glass typically works better for those. So again, just going through, we can use different combinations of PVB to give us different benefits like color and acoustic in addition to the baseline levels of protection. So that's what I had prepared for you guys today. I think I got a little under a minute left. If there are any immediate questions, I'm happy to answer those. Or again, we do have a table outside and I'm happy to welcome any of you for a conversation later today. Thank you very much.
Thank you, Bob. So the format that we like to do here at Zak is that we let the speakers speak and then there is opportunities to talk to them outside of this, unless we are in a, let's say, format where we have a podium discussion, which we believe is the best way of taking maximum advantage of your time. So the next presentation will also be with the topic of glass. Ahmed alluded to the fact that we have the Turkish glass as a group of companies involved here with the Zak conference. So I'd like to ask Tansu Kumru from Turkish Glass to come up here and talk to us about what they can do for us in this marketplace. Thank you very much.
Thank you. It's wonderful to be here with you on behalf of Turkish Glass. Today, I will introduce you to Turkish Glass, a comprehensive solution partner for the most demanding projects all around the world. Turkish Glass represents the glass manufacturers and glass processors of the Exporters Association of Turkey. The Turkish glass sector consists of a large and powerful ecosystem combining manufacturers and processors. They are interdependent and complement each other to provide excellent project management with customized glass solutions coupled with on-time delivery. Every project is a unique journey for the Turkish glass ecosystem. This journey begins with a project-specific glass consultancy of a Turkish glass manufacturer. As the glass consultant, we customize glass solutions according to the specific needs of your building. We do this by undertaking detailed technical calculations to determine the ideal glass type and thickness. Then the Turkish glass processors will continue this journey by supplying the right glass of the highest quality and at the optimum price in cooperation with the manufacturer. We believe that every project has its own unique story. As a comprehensive solution partner for your projects, Turkish Glass is always beside you from the beginning to the end of this journey with the support of its powerful ecosystem. Turkey has many years of experience in the glass industry with an architectural glass production capacity of 200 million square meters per year. This amount is close to half of the United States' yearly architectural glass consumption. With its high production capacity and powerful ecosystem, Turkey is a global glass production hub for the world. Turkish glass, with its high production capacity and powerful ecosystem, combines high production capacity and superior quality and an extensive product range. We are able to respond to all needs, such as energy efficiency, safety, security, bird protection, and noise control for residential and commercial buildings. Moreover, Turkish Glass has created a BIM smart objects for its products. Every one of our product ranges is now available as a BIM object to present all alternatives while choosing glass for your projects. Turkish Glass, with its sustainable products, technologies, and global excellence, is not only the solution partner of today, but also tomorrow. That's why we are continuously developing new products in our science, technology, and design centers to support the unlimited creativity of architects and to remain at the cutting edge of the glass industry. Having all of these capabilities, Turkey exports glass products to 175 countries, providing customized glass solutions all over the world. Now, I would like to share with you some of the residential and commercial projects that are representative of our world-class capabilities. First of all, let's take a look at examples in Europe. You can see the signature of the Turkish glass industry in important projects in many European countries. In Bulgaria, in this special project, our glass products provide visual integrity with harmony, with horizontal and vertical profiles used in the design while minimizing heating and cooling expenses. This building, which is designed to resemble ocean waves, ensures maximum energy efficiency with an effective holistic insulation system, including bricks, window profiles, and glass units. This palace is one of the great historical landmarks of Hungary, built by the Archduchess of Austria in the 19th century. In transforming it into a luxury hotel, the architects combined a sense of place and cultural heritage to create a hotel full of meaning for today's guests. We supported this project with our high-performance heat and solar control glass. The Victoria Tower renovation in Brussels aimed to transform the existing structure into a low-energy and fossil fuel building. The facade with solar control low-coated glass adds extra value while maximizing the efficiency of ecological resources. This tower in France is a dynamic oval shape with gray and silver glazed elements combined with a white metal structure that allows for magical nighttime lighting. Next, I would like to show projects completed by Turkish Glass all over the Americas. In this building in New York, we developed glass solutions with silver characteristics that are compatible with the anthracite material used in the facade design. Located in the center of Silicon Valley, Tower 27 serves as housing for 20,000 new technology employees. We developed a glass solution with 50% light transmission and a solar factor value of 0.33. Due to the hot island climate of the Dominican Republic, the best choice was our glass products with 50% light transmission and 0.25 solar factor, which helps both the comfort of the hotel guests and reduces cooling costs. At the same time, our glass product, with its unique bluish reflective color, has been chosen by Marriott hotels worldwide. As you can see here, this building near to the Mexican border with Texas needed maximum solar control due to the region's extreme temperature. Our special glass with 40% light transmission and 0.22 solar factor was uniquely suitable for this project. In addition to large projects, we provide services for various unique projects in the United States. We collaborated with an architect who required a green facade based on the influence of the regional factors for a tower project in Bolivia, South America. This is a fine example of the creative capabilities of Turkish glass. The aim of the Turkish glass in the Americas is to be the solution partner for the most demanding projects in many different regions of the continent. Now, I would like to show some unique projects from Turkey. We have developed new products for special projects such as Istanbul Airport and International Financial Center. The facade glazing in the airport ensures maximum energy efficiency, safety, security, and noise control all at the same time. The Istanbul International Financial Center was completed less than 2 years with a total of 1.7 million square meters of glass units, including IG units, laminated mirror, and tempered glass under the extremely challenging conditions during the pandemic. The planning and coordination power of the Turkish glass ecosystem made this possible. Additionally, in our bank tower project, there are 2,760 different types of triangular glass units with a variety of sizes. This highly complex project was completed in 18 months with end-to-end planning by Turkish glass manufacturers and processors. In this business center, we ensured that each slice on the facade took on a different visual with the same glass product. Solar control Lowy glass with 43% light transmission and 0.28 solar factor was used in this project. Istanbul TV radio tower, which has already become one of the city's landmarks, gets its extraordinary elegance from the glass. The strong bond that glass has established with light contributes greatly to the formation of the architectural form. Grey tinted float glass and laminated Lowy glass were used with its low reflectivity, high heat and solar control to ensure continuity between indoor and outdoor spaces. This port management building, which is inspired by the container, receives natural light not only from the front and rear facades, but also from above with a special design using solar control Lowy glass having high light transmission. Built on an area shaped by archaeological findings, the museum hotel preserves historical texture and brings a new approach to hotel building design. While staying at the hotel, you can have the chance to see very special mosaics with traces of 13 different civilizations. In accordance with the spirit of the design, 7153 performance heat and solar control glass was preferred to preserve a sustainable low energy environment. Heat and solar control glass with 50% light transmission, 0.27 solar factor was used on the facade, representing the flow of water in the State Hydraulic Works building in Turkey. In addition to Turkey, Europe, and Americas, we also continue to engage in projects in many other locations. We play an active role in a wide variety of projects in Africa, taking into account the culture of the region. We have met demands for glass, reflecting the colorful culture of Africa at the Dakar Stadium in Senegal. We produced a solution for the seaports complex in Rwanda, taking into consideration the climate, humidity, and temperature of the region, with a glass having 58% light transmission and 0.32 solar factor. We have met the glass needs of the Congress Center in Equatorial Guinea, which has a unique exterior design. In addition, we have produced solutions in line with the needs of the hotel projects in Africa. The Nigerian Ministry of Finance project was carried out with the aim of modernizing the city and improving working conditions. This building was covered with grey glass that provides effective solar control while allowing the view to be seen clearly with its low reflectivity. In summary, as the Turkish glass industry, we are the solution partner for both today and tomorrow. With our environmentally friendly glass solutions, we are continuing to add value to human life all around the world while protecting our planet. We believe that together we can reshape the future of the construction industry using our eco-friendly products. We welcome you to the new glass age together with Turkish glass. Okay.
So that brings us up to the end of the first session. We have right now a short break for you guys. Now, the next person that I would like to ask to come up here is Ben Mitchell. Ben is one of the authorities in the finishing. And you all know that the material that we are using in facades and curtain walls and building envelopes is pretty boring. You know, it's the finish that makes it very special. And he has always been, for me personally, the go-to person and the number one person that I would go to when there is questions about finish. And I'm very happy and glad that he will come and speak to us today about and share his knowledge about the architectural finish. Thank you very much, Ben, for joining us.
Thanks, Attila.
And please welcome him. And make your own judgment after his presentation.
I'm going to make your world more colorful. That's all a paint guy can do. Our experience we have, I spent 6 years as a bench chemist formulating coatings in the laboratory. I then found my cheese and got out of the laboratory. Went into tech service for a number of years, traveled globally for quite a while before moving on into the sales, marketing, management kind of role where I am today. Project journey, the 4 bullets that we'll hit as we start off this: project excellence, continuing education, defining quality, and the color effect and finishes. Project excellence, we pride ourselves on getting involved from the design phase early on, and there's a lot of decisions that I'll get a little more into as we go about, you know, whether it's liquid or powder, 1 coat, 3 coats, polyester, PVDF, FEVE. There's a lot of things that we can involve, and any coatings, there are pluses and minuses. If you want it glossy, if you want it dull, do you want flexible? There's a lot of give and take that we can help with those kind of decisions. Workshops and seminars, we do a lot of online stuff, especially post-COVID. We do more online, which was kind of a transition to where we got used to, and they work pretty well now. We still do in person whether it's a design team or an entire firm. Sometimes we'll do one at an architect's office, and then they will conference in all their other locations around the country, or around the world for that matter. Defining quality. Quality can mean a lot of things to a lot of people. You look at your building, one of the first things that people see is the finish. So the wrong finish can really affect the appearance and what appears like a poor quality building when it may not be. It may just be the wrong coating, where maybe a coating that was really intended for interior was used on the exterior of the building, and it doesn't perform well. Sustainability, obviously that's top of mind with many of us, and we can work with our new BioCore powder coating, which has been developed in Europe, and it can help you get lead points. Can be up to 8 points. It is produced from bio waste, and the key is that it does not come from any food source bio waste. Right now it can reduce about 25% the CO2 required to produce powder coatings. We hope within the next year or so that we can release this in the US, but it's working on it. It is available currently in Qualicoat Class 1 and Class 2. It's not available yet in Class 3 in Europe, but we intend to get it to that point as well. This is one that I get asked almost every day. Powder is much better environmentally than liquid. Not really. If you look just at the application point, there's no VOC, absolutely powder wins. If you look at the liquid coating, I think I got a pointer here. Yep. If you look at the liquid coatings, you just paint it out of the can, there's a lot of VOC emissions. If you look at your CO2 emissions, liquid coating is comparable. But if you go up there with the liquid coatings with a thermal oxidizer, which most of the lines in North America have, they not only capture and destroy the VOCs, but the energy from that process of heating and burning them and destroying them will power the finishing oven. So you use a lot less natural gas to cure the paint, because it all runs, well, 350 to 450 degrees, depending on the coating. So you can save the energy required to cure it because you're using the VOCs from the paint. So as you look cradle to cradle, there's a lot of pros and cons of both. Mar resistance of powder on railings and many high abrasion markets, absolutely. We come to the market with both together. So I'm not going to tell you all the bad things about liquid or the bad things about powder. There are pros and cons to both. We help you look at, is it a corrosive environment? Is it a high abrasion environment? What is that environment? And we will help you. Do you need something to protect the substrate? What is the substrate? Is it aluminum? Is it steel? Is it stainless? What kind of environment? Is it on the coast? Is it in Canada? Wherever it is, there's a lot of different questions that we can help. And we will give you the pros and cons, and you tell us, I want powder. Okay, do you want a super durable? What do you want? We're going to help you do that. Then the color effect and finish. In my career, which I was skinny with brown hair when I started, so you can tell it's been a while, metallics were probably 5 to 8% of the market, and they were fairly popular as the metallic colors were coming from Hartford green, bone white, etc. You started getting your champagnes and colors to basically mimic anodize is where a lot of those come from. Over the years, then you needed a clear coat. There's a lot of things. Well, then we went more and more to micas. We can get virtually the same color with micas we can with metallics. Micas don't degrade and oxidize like a metallic flake does. So over time, the use of clear coats to protect the mica has almost disappeared. It's almost always 2 coats and not 3. We can still do it. You can put a barrier coat, or you can do a metallic with clear. There's a lot of things you can do, but for the most part, it went from 5 to 8% metallic look, mostly aluminum flakes, to today it is probably 60 to 65% of the 2605 fluoropolymer coatings are some kind of a primarily mica. Some metallics, but primarily mica. And if you look at the top 10 selling, they mimic anodized. They're clear anodized, champagne anodized, light bronze, dark bronze, etc. But again, depending on where the project is, what that project is, what the substrate is, the quality of the coatings, interior or exterior, with these strutted systems using a polyester or acrylic interior, while you have the fluoropolymer exterior is becoming more and more the rule, not the exception. So there are some hardness advantages to the interior. Maybe you want a powder coating interior. It's going to be hard, mar resistant, but I want that fluoropolymer on the exterior. We can make those where the colors match or not, whether it's a coil coating, a powder coating, or a liquid coating. We supply all, and we will make sure that all of those match each other in not only color, gloss, but performance. You don't want one that looks the same, but 5 years later, no longer looks the same. Some of our digital tools, and we have a lot of digital tools where you can get the, I think I'll go on another one here. Our color design by Axalta, our Color It toolbox, where you can go in and you can get the images, you can get BIM objects, you can see all the colors that you can then capture and put into your modeling. All of these comes within our consulting. You can do self-directed, but we're always available to help and go through any of them as you go. We do a lot of case studies and don't really have time to go too far into any of them. But we have buildings all over the world that we have done for a long time. And anybody that might say, who the heck's Axalta? We used to be DuPont. DuPont coatings were sold and became Axalta. DuPont still exists, but not in the coatings world. It's all Axalta. Then the world I come from, which originally was Duracoat coatings, became Axalta. So we have several others that have been by acquisition that Axalta has grown into about a $5 billion company. We're in 140 countries around the world. As you probably are well aware, in Europe it's pretty much all powder. So most of the projects we show in Europe are going to be powder coated primarily super durable. In the US, the exterior is pretty much always a fluoropolymer, whether it's the ultra durable, we call it, powder coating that's going to meet the AMA 2605 or class 3, or the 70% PVDF liquid that is on the exterior of these buildings. And we have case studies we can share with you. We have weathering, we have long-term data. Kind of as the way we look at, the way we go to market with liquid and powder, our warranties are the same. If you choose a super durable powder or liquid, the warranty is going to be the same. If you choose a fluoropolymer powder or a fluoropolymer liquid, the warranties are going to be the same. So there's other reasons you may choose one or the other, and that's fine. That's up to you. We will support either way, and we will make sure that they match and that they perform equally. Our Vibes Trends is a magazine that we do once a year, and it shows a lot of the sociological and psychological reasons that some colors are selected. You look at some things just like the NCIS TV show. If you ever watch that, look for the colors. They don't have a bunch of beige offices. They're all a deep red or an orange, or there's a lot of colors there, and I don't have time to go into it, but there are psychological reasons why they use those colors to give you the overall subliminal, if you will, message that they're trying to get across with colors. And the same way with your architectural buildings, whether it's interior or exterior. So I think that is it. Thanks for your time. Thanks, Attila.
Thank you very much, Ben. So let's be honest, did I promise too much? So this guy really is the man himself when it comes to the finishing. Thank you very much, Ben. Really,
I didn't invent paint, but I was there when it was invented.
Thank you very much. I'd really like to know what color one should use to get somebody to sign a contract. You know, if we can find that out, that would be great. So the next topic that we have is actually one that a lot of us have been looking at, and that's sculptural facades, especially in an environment like, I would say, in a harsh environment, like we see here in southern Florida. So I would like to introduce Juan Betancur from Adrian Smith Gordon Gill, who will be talking about exactly this. Thank you very much. Thank you.
Hello, everybody. Can you hear me? Great. Thank you, Susan. Thank you for having us here. Obviously, I think a lot of people have seen the building, have a lot of questions about what's going on, so we'll talk about that a little bit. But I'd like to kind of introduce ourselves. I'm sure you're not totally familiar who we are. We're an architectural design firm out of Chicago, Illinois. We focus on highly sustainable, large, complex buildings. Some more principles. We do work all around the world, all out of Chicago. And you're probably seeing us primarily for this stuff. Tall buildings, kind of in faraway places. What is interesting to me about this slide is that they're all different. Yes, they're all tall. They're all kind of glass buildings. But the philosophy, we'll talk about philosophy and principles. Principles are a key thing to us. Those are designed, excuse me, this is going the wrong way. Can I go back? Oh, here we go, sorry, thank you. Principles, we'll talk about principles, and that the approach we'll take to design is based on a set of principles which guide us in the way we go back to thinking about how we deal with all projects, no matter scale or typology or any of those things. So once again, all over the world, you know us for these things, but we spend a lot of time doing performance venues and world expos and hotels and kind of smaller buildings that we really like to kind of get into the theater world as well. And we do a lot of master plans around the world as well, so that's an important component, the multi-scale design work for us. Sustainability obviously is a big component. Carbon, our approach to integration of carbon studies, analysis throughout the design process is a big component for us. So that's kind of how we begin to kind of study the basic principles of how we go about it. We create a lot of tools ourselves to kind of begin to understand our carbon, both from embodied and operational carbon. They're big components to the projects. In 2018, 2019, the studio took on the idea of creating a set of books to kind of culminate about 10 years. 2006 is when the firm was founded, and kind of began to look at those first 10 years, and there was a set of kind of publications that we're looking at. One was primarily on facades that I spent a lot of time dealing with, and really begin to kind of look back at the work of the firm and understanding kind of catalog. And it was an interesting process. Here's kind of what the book looks like. An interesting process to understand how we approach facades, looking back, help us going forward, and begin to catalog. And then we came up with this kind of 9 study areas or performance spaces that the facades really fall within there, right? So all your controls, that kind of different aspects of the facade that we can begin to look at. So when we started looking at this, some examples of how we went about this, we case studies where we said, okay, here's a building that we worked on. It has operable shading, it has photovoltaics. What does it begin to lead? And begin to look at the projects that were more successful and how the relationship between those components come together. Which ones are most, which ones get built, which ones move forward, what elements of these kind of begin to work together to understand their relationship. And so that's a building, this is a building in Korea that has photovoltaics active on it, and really how those things kind of really become together and understand our approach and how that affects the work, and we'll talk about the work in a minute. So there's an example of that. Here's another example of a project we're working on in Egypt, and those relationships. So that's an important component. When we get to talking about our project, so this is a project that we were called to design in 2016 by Oko. Oko is our client, our developer that we're working with. We have a great relationship. They're a great group of people, and Revuelta Architects are our architect director. I think everyone knows who they are. And this Simone, he's kind of the rest of the group that's working on the project. We came up, and I think everyone's probably familiar with the site, exactly where it is, right after trying to go to Key Biscayne, interesting site. And we're looking to develop a residential building. So for us, it usually starts with understanding the site, understanding the parameters, what is it that we're trying to achieve. When we spend time looking at residential buildings, and we'll look at this in a second, in a site like this where water is such a primary element, how do you give everyone views? This is the conversation we have every day. How does everyone, if you're buying a condominium here and you're not on the front, you're in the back, how do I get views to the water? With a very narrow site. So it's not a broad side where I can begin to, I think this is my pointer, nope. Where I can begin to open up, split the building out and have a big face. This is gonna be a narrow side, deep on the side. How do I get to that? So we'll look at that in a second. So really understanding solar analysis, radiation, is there anything that we can do that we can help begin to shape the building and shade the building? And we spend a lot of time in this realm going back and forth with our analysis. And then views. Obviously, if you're looking at residential buildings and you're trying to sell units, the views of the bay are the most important thing. Every unit needs a view. That's kind of a directive from our client. Every unit needs a view of the bay. How are we going to achieve that? What's the process for doing that, for laying out a building that begins to do that? So looking at the views, what's surrounding, what's the neighbors, how can we get different, so we look at different elevations throughout the time, in which ways that we can kind of achieve the best views. So what we did is pretty straightforward, simple, it's not that complicated. We have the basic massing of the building. We wanted to maximize the number of units we can get on the front. So we cut the building in the back, as you can see down here. I don't think I have a pointer. Down in the back, and we added that piece to the top. We also flare the building. So when we do these residential buildings, we like to, they're almost beginning to be flared in a way where the units in the back are looking past the units in the front. That way we can create views for everyone. So that's where the building needs to have this kind of almost boat-like shape, an organic shape in this one, in a sense. So that study of understanding those relationships between massing, site, program, something we spend a lot of time going back and forth, trying to program the building, finding the area. So that becomes one of the major design elements in the building that you've seen as you're driving nearby. The building really kind of comes at you from the back. And we just cheated and took all that area. They had the least sellable ability, right? The cheapest units you can find, we took them and made them the most expensive units. So that's a value add, which allows us to pay for a huge cantilever, right? So how do you get that money back from the cantilever? By making those the most expensive units you have in the building. So here is a diagram that kind of really begins to explain that. You can see as we start kind of beginning the massing process, how to get those units really views out. Begin to kind of flare the building back, create stepping, create kind of this flare effect that you really can begin to take advantage of the views and maximize them. And then every unit needs a balcony. Every balcony wants to be 8, 10 feet. So once again, begin to reinforce that concept of applying balconies to all the units. So it's not a big floor plate. They're typically four units per floor. So you can begin to see how you dissect that pretty quickly, 6 units sometimes. Of finding the best way to utilize that space and getting those views out to the bay for everybody. Really a driving factor. There's just enormous versions of studies of how to get the maximum usage out of those spaces. So everyone in the back, this is the view in the back. You can kind of begin to see on the top right view where you have the building and you can begin to step outside of the building. Very early on studies of the massing, can I see the bay from my unit in the back? A lot of time spending that. You can see the different studies of different massings, how it doesn't work, and how the massing, as you begin to kind of look at that shape that we kind of end up towards, begins to maximize the view. So we spend a lot of time in the massing form, taking basic, simple massing forms, a square, rectangle, and analyzing them from a performance, environmental, programmatically, until you find the right shape for that site. And that's where the buildings all have a very unique expression. So here you go. And then in the process as well as of programming. How many units, how big are the units? We're working with a developer, so this is trying to find that right balance, right equation of value add to cost to relationships. How many more units can I get in the front? They're more valuable in the front. How do I shift the massing? How do I get the bigger units? So a set of sequence of studies that everyone's pretty used to doing on massing relationships to get to a final shape where you can see the kind of the final allocation of units. It's about 119 units. It's not a huge building. It's 44 stories, but it's a small floor plate. So that process, that restacking and restacking and restacking of the building that we constantly go through. And then as you look at the floor plates, you can see that here there's there's 44 units at the bottom zone. There's 4 units. They're pretty straightforward. Every unit has direct elevator access. So that's a big difference. So these are high-end, high-luxury units. So access directly for the elevators from every unit. So you can see in the front, you come out of your unit elevator into a little vestibule and out to your unit, and same thing happens on the back units. So everyone has that personal access, which makes the ground level a complicated place. And as you work your way up the building, I think you begin to see that same relationship per floor. These are bigger floors. As you go up, once we get past the cantilever, the back units begin to have a second balcony on the back. They take advantage of the views. But you see that view out to the bay for everybody. That's kind of a big component. Excuse me. And then obviously the top floors, 2 units per floor. They split the floor half and half. And then the top penthouses, I think there's 2 penthouses. They go double height towards the top. So it's a pretty straightforward floor plan, and just really that flaring out of the building is really what creates that value added. So as we got the massing settles down, we begin the process of looking up what the building looks like. It's pretty simple, extruded form. There's not a lot of complex geometry. So begin to look at that, and really clearly early on, the understanding the team had that the balconies are really everything here. There's really nothing else to this building. There's a shape. The shape is simple, but it's elegant. It works well as it flares out. How do we accentuate it? How do the balconies become a major element in there? There's a lot of studies about their geometry, their soft, hard edge. How do we deal with those geometries? Very early on in studies, you can see it's a very, at this point, we're looking at a kind of simple balcony edge, raised glass, guardrail, let the water drain out the front. Very standard Miami balcony that everybody's used to. But it just was not enough. It was just not separating itself in a way that we thought the form wanted to have a higher expression, wanted to kind of play more with the form and really kind of take that expression to a new place. So we started kind of really targeting that edge of slab. What is there? What can we begin to do that is different? Usually it's this design where the glass is in front and you let it drain behind, or you lift the glass. Everyone's kind of standard these. It was clear from the beginning that the client did not want to drain internally the balconies, which is also very standard. We've gone through that process. And what we ended up beginning to look at, it's what is going on with the references. So Missonia's our client's building on the bottom right side, and they have the glass in front. But really that kind of standard expression, I think that's the Foster building. And what I was doing, what can we do differently? How do we take advantage of this problem to create an opportunity? Usually looking for those problems to create opportunities. And we begin to look at, so here's an early rendering when we said, okay, can we begin to take that edge slab where it's flat? There's a lot of portions of the building where the glass is flush and it's there. But as we come to the balconies, can we begin to express that differently? Can we create an edge slab that is different, that caps the balcony, that slab, which is not typical. You don't see a big cap on the slab because now you're going to get a problem with drainage and it gets complicated, and we'll deal with those issues as we kind of begin to look at it. But really you can see the curvature. In this zone here, we begin to accentuate the curvature of the balcony, and as it wraps around towards the front and really accentuating the form. So we spend a lot of time exploring in that area, that zone, and this kind of metallic reading begin to kind of pop up. We see it here, how it really begins to kind of transform, right? It goes from if you go back to the previous image. So we're going from flat to angle to flat. This is a warped angle to a flat again to a kind of a lip. So it has complex geometry. It's now been introduced into the project, which we didn't have before, but it gives you that elegance and that kind of sophistication that takes the building out of something else. And it really begins to play with light, which is something that we're interested in. How does that edge become to kind of pick up the light? I don't know if you've driven by the building, you've seen that those silver bands really play with the light. So that was the study that began to be done, and really kind of getting up close to that edge and understanding what it is and what can we do with it. So this diagrams begin to show where those edge slabs are. Obviously in the front and on the sides, the middle portion of the body really goes flat glass, and that's where it goes taut as much as possible. And understanding those relationships, number of them, where they are, how they come to the building, you can rather begin to see it as the renderings, the building begins to be rendered more closely. And that relationship of their thickness. So looking at the thickness of how big are they, how are these made, how are we going to get them on the building, we begin to do a lot of studies based on that, where they are, their color, their materiality, their sheen, their relationship to the massing, just kind of getting really into the detail of the form, exploring that as much as we can. And then we finally got to the understanding of what they are. So there's a relationship of that cap. The building is a post-tension structure. So the tendons are at the end. Usually don't want to cap the tendons because you have to make sure they're not rusting away or having any issues. So now we're putting a cap on top of the post-tension cables, and then we have to now drain the balcony as well. So those become, excuse me, the two biggest challenges as we move forward. So as we begin to see the exploration of those spaces and its relationship to the window walls, the window wall crosses over the edge of slab when it becomes a flat detail, becomes a detail that becomes interesting to us. That's where the flat glass is. So you can see as you go back in the section, the cap, and then the cap goes flat as it comes into the flat glazing portions. And then as we start developing the piece of slab, there are a number of versions of them that we have to all map and draw and understand geometrically. And the decision was made at this point that we thought the best material for these were GFRC. So metal panel, metal cap was not going to work because we have warped panels. So metal was a no-go. And we liked the team and the client really liked that kind of earthen feel of the GFRC. But the building's silver, so it's not raw GFRC, which I think we've seen in town before, and then when it's done, it's pretty straightforward. This is a painted GFRC with a metallic finish on the waterfront in Miami. So that's good. We'll look at that. But yeah, once again, the collection of the types. How many do we have? What's their profile? What's the geometry? How they relate? Really, the issue really becomes in this zone as you transition from the flat to the angle portion warp panels. On the back balcony, each one is generated separately. And you can see, so these are some more preliminary details that we were working with through kind of design development. How it's inserted, originally the slab came out and the GFRC just kind of capped around it, which you can see in that last, I think this is probably the most relevant one. Slab comes out, you see the tendons, caps on, it's locked in place, it's not removable, and there's a drain within the floor that allows to veer the water out away from the balcony below. That's design intent. And you can see what is that, 8 different versions of the same detail as it moves around the building and how we deal with that. In the process, we came to the understanding and the work through both Revolta's work and the manufacturer. The GFRC is main manufactured in Turkey, and it's put on a ship, and it's shipped to Miami, that they wanted to have these panels removable. So you can get to the tendons and get to the slab you ever needed to. So now what was encrusted, for lack of a better term, into the slab is now hanging up the slab, supported almost like a curtain wall. So now you got an edge slab member that has the waterproofing, the enclosure of the building is really back here or back where the facade is. This is really just hanging outside. There's some insulation in there, and there's some fires. Stop. But now you're going to adhere these to the slab. And the methodology for these began that we're going to encrust them or cut into the slab as a set of slab edge wedges or cutouts into the slab edge. So typically you will see a slab edge in any building that you're familiar with that is continuous. We have a serrated slab edge, which I have never seen before. They're very interesting. I think this picture, I like this one. I've never seen an edge slab look like that before. The tolerance for those pieces is not great. So that's a complex detail that we spend a lot of time with the contractor, a lot of time with the client, the manufacturer, trying to get these GFRC panels. You can see how they're, if we go back, how they're bolted on. And then you can begin to see the edge. So they're beginning to be installed, and then the spacing, the tolerance, it's a fine detail. But they're beautiful. And then that serrated edge, which we've never seen before, really, I mean, as they moved up through the building, the contractor really understood it. The first couple ones are more difficult for installation than the next ones. But they're all on, and they're all beginning to move on. I think they're on level 40, some with them already. The separation, you can make this as well, the incorporation of water drainage. What else is incorporated into the panel? I think you can see it in the mock-up panels in a second. The tiebacks for window washing are incorporated into the track as well. So the panel is it's a complex panel. 3 layers, so you can see the raw panel on the side is just pure GFRC. It has a kind of a primer base, and then there's a techno flooring. I put it in there because I don't want to remember what the paint is. There's applied to the top of the panel, and it's a 2-layer process to get that metallic feel. So the building really shimmers and it picks up the lights beautiful, and the geometry is constantly changing. So you are getting this playfulness of light throughout the day, throughout the night. Here's kind of the underside of the panel. So there's a drain cover that's added to that to kind of spout the water out. Our tiebacks, you can see here, we're checking our samples, make sure the paint, lots of samples of GFRC paint samples to get those to match design intent, to get that 3-layer, that flop, that kind of depth. A lot of the panels were very flat originally, and we wanted them to have that kind of depth of metallic paint, which is not typical on a GFRC panel. So that was a good process that we learned through. You can begin to see them here on the building now. They're already being cut in between, but what's beautiful is this, it picks up this white light. That line on the edge is always kind of shimming and shining as the geometry begins to move and change. And they begin to be installed. That's not the color of the glass has the film on it. I get asked that all the question. A lot of work that's been going on as well recently with the relationship between the slab and the GFRC, the tolerance in there and how that reveals term finished. That's what you're really looking at from your unit. So there's a lot of work being correlated for that. The other portion of the building that we're working on now, so the typical facade is it's all designed, it's all manufacturers being shipped, it's mostly installed. Is the back, that curved panel, that big GFRC wall that you've probably seen raw at this point. So that geometry for these big curved panels and how they're installed and that we're working on, standing on that floor there is an interesting understanding how they're going to hang these panels from that side. And then a lot of explorations on what they look like. There's mechanical space behind them, the incorporation into louvers, drains, all those things that we spend a lot of time working through. I think this has been finalized already in the last couple of weeks, and they're being manufactured. And that's kind of the component that we're focusing on right now. And then as it relates to the podium as well, it's kind of the next phase for us, so really that portion there. And as the GFRC wraps around the podium as well, is kind of our next area that we're tackling. And there you can see the back, the big cantilever element. So this is the area that was removed and put on the top to get all those units back to be more valuable. This is from a couple of weeks ago, I believe. This is coming along. It's a pretty interesting cantilever. And I think these are the photos that were taken, I think, 2 weeks ago when the building topped off. So the building's topped off now, completely structured. You can see the cladding is about halfway up. The units are beginning to be mocked up inside. And this is kind of my favorite photo right now. So that's it. Thank you.
Juan, thank you very, very much.
Thank you.
What an interesting project and very challenging. So the next point on this agenda is actually a podium discussion that I'm personally looking very much forward to. But before we get to this, we need some time to kind of set up chairs and so on. I wanted to remind you of 3 things. Number 1 is, if you're here to get credit for your AIA, you need to register. And it's important that you do this on your way out to make sure that you're getting the credits. There is a desk set up at the entrance, and they will do this. The second thing is, we will have lunch after this. In fact, this podium discussion is essentially standing between you and your lunch. So once this is done, there will be lunch. And the hotel is asking us to advise you to not come in with your lunch into this room. They would like for you to stay around, which also has an advantage that you can essentially network a little bit with people and talk to people that you don't know, right? So that's the whole purpose of coming to meetings like this. And then the third thing is that we have a reception after the last item on this agenda, which we are expecting to be somewhere around 5-ish. The program says 4:50, but we are running about 20 minutes late. So make sure that you're staying around because it will be fun to spend some time together. Now, talking about the next item on the list, it is a topic that has been very much neglected for years in southern Florida and in this marketplace. But now it is gaining traction, and we have some really, really, really knowledgeable people on this very matter here. So the topic is passive shading and active ventilation. Screen facades that provide air, shade, texture, and beauty. So that line obviously wouldn't come from somebody like me who's a contractor. It's coming from an architect, as you can tell, right? So I would like to ask Kobe Karp to come up here. Kobe, to come up here and introduce your panel, first of all, the people that are here. Guys, give him a strong hand. He's one of the most famous architects in Miami. Kobe, first of all, thank you very much for accepting this and being on this. And what I would like you to do is to introduce your panel, the topic, and then get started, okay?
Hi, so my name is Kobe Karp, and thank you very much for being here. I did not accept it. I was told to be here. Jessica said if I don't show up, I have a big problem in Wynwood. So Jessica is right here. Jessica Rammig Goldman is one of the best and most knowledgeable developers we've had in Wynwood ever. She is the reason I am in Wynwood. What she and her family and her father have done there are the prelude to our establishment there. I have Mr. Anshuman, a very, very dear friend, very knowledgeable architect who has done many, many projects, which I think you'll find interesting as his thought process is completely different and radical. If you allow me, I'll introduce also Vic. Vic has a construction company specializing in facades and treatments in the tropical weather in a very cultural and artistic manner. Vic Crespin is a legend in the construction when it comes to those kind of things. Alan, you'll have, who did I miss? Of course. Come on up, Jason. You're the first one in line. So Jason has the company that actually does the installation. Thank you very much. Come on up, guys. Alan, don't be shy. So let me start, if you allow me. What I asked them to do is, because we have a bunch of images, and I asked them to just continuously spin the images so that you have inspiration behind us. If you don't mind, I'll sit next to you, Vic. And basically, what I wanted to do is start with Jessica, and to just talk about Wynwood, about art and culture and architecture, if you allow us. If you would enlighten us about your ideas and inspiration, or some of the things you've done with Vic, you know, that would be enlightening, I think, for the crowd here, because they have seen the garage, they have seen the inspiration in Wynwood, and they probably have driven by and have had thoughts, but now they can get behind the scene kind of a feeling. Is that right, Vic? So if you can inspire us and enlighten us, Jessica, I'd like for you to go first.
Sure, thank you. Thank you very much for having me. Really excited. So I am obsessed with the marriage of art and architecture. And I believe as developers, it's really important. We have this opportunity to, this is one of our projects, we have this opportunity to put our fingerprints on the planet. And so how do we do that? In what ways do we do that? How do we kind of infuse things that are inspiring, that are that push the envelope with creativity and design in the neighborhoods where we build? And so as a company, my father founded our company over 50 years ago. His name was Tony Goldman. And we revitalize neighborhoods. So we go into neighborhoods very early. In the case of Wynwood, there was very little happening in Wynwood. There was nothing interesting architecturally. You know, this is another one of our projects that I'm incredibly, incredibly proud of and excited about. And so, you know, Wynwood was a neighborhood that was kind of forgotten, unappreciated. And so, but what it had was a really incredible kind of core of graffiti. And so what we did is we believe that art should always be pushed forward. This is another kind of example of one of our projects. And this one in particular, as an example, is kind of our statement around the fact that in Wynwood, we don't want to see art disappear. And as buildings kind of go vertical, because the neighborhood was all horizontal, it was mostly single-story industrial, and as we start to go vertical, how do we make sure that we infuse art into the community? Because the community is very much based on the component of art and creativity. And so this, as an example, was kind of our statement of taking the Wynwood Walls, which is one of our projects. I'm the lead curator for the Wynwood Walls, and taking the Wynwood Walls and going vertical and kind of creating all of these different canvases for art integration. And so, you know, we're here talking about facades, and so, you know, the facade of a garage can be very ordinary. It can actually create blight in a neighborhood. And so how do you look at all of these different opportunities as canvas? And so this was another one of our projects. This was almost 30 years ago that we built this. This is on Collins Avenue. And we wanted to take the character of the neighborhood, which was the Art Deco district, be really super respectful to that character, and by keeping the facade on the ground floor, and then essentially kind of hiding what is typically really ugly. And so we did that with foliage. And so it depends on your neighborhood, what's going to work, what's not going to work. But, you know, I guess, and we'll talk a lot about it. And Vic kind of built one of my most favorite projects, which is the Wynwood Garage, which I think is really like a sculpture. And so that's the Wynwood Garage. And so this was really hard to do, like really hard to do. And it comes with a lot of commitment as a developer, because it's going to cost more money, it's going to cost more time, it's going to require real expertise, like Vic has in his company. This required 3 engineers, this required a facade. This is almost like a puzzle, right? And so how you put things like this together. But this was one of the first projects to go up in Wynwood. We needed to make a statement. We needed to kind of set the bar as developers around kind of what are the expectations for this neighborhood. And so not everybody adheres to that. We don't own everything, but we hope that what we do is lead by example. And I'll leave it there because there are other people that are very wise that can add to that.
Vic, you're next. Tell us, how did you do it? How did you build it?
Right, so this is actually City View Garage, but what she was talking about, the challenges as a builder is, you know, and I think our organization has a heightened sense for this, but we really feel that how we execute has to be excellent to respect the art, to respect the design, and to create that whole image and feeling that Jessica's talking about. So it requires incredible amounts of collaboration. I was just talking to someone earlier, I said, you know, if you think about the moment that we got involved with Jessica's company to the time we actually started construction was almost a 2-year journey in collaborating with the artists, getting the fabricators involved to understand what our challenges were, and even just getting the property ready for construction based on the logistical challenges with doing something like this. But it's exciting and it's really rewarding to be able to drive around the city of Miami, which is a place where I was born and raised, and see how we have stepped our game up because of the leadership provided by people like Jessica and Alan and Kobe. And you know, when it comes down to cutting the metal and making it all, it's a guy like Jason who really deals with that in the shop. And it's amazing how much goes into this. This corner here on City View Garage, there is not one panel on that facade that has a duplication of color. Wow. You have to, when you drive by that, you see there's motion in the paint job. And those are very difficult panels to fabricate. They're bent in 3 or 4 different directions to create that relief, that texture. And it's just amazing to be involved with something like this. And you know, Alan and I collaborated on the Collins Park Garage, which I think you'll see in image here soon. And that was really an interesting scenario because it was a competitive process for the city of Miami Beach. So we teamed up and we had to present a design with a guaranteed price. And Alan will tell you that we really challenged him as a designer, but he really also challenged us to be able to execute and deliver something that was really going to be iconic, because I think what we built for Miami Beach is just going to last for a long time.
Jason, tell me, these screens that you're seeing in front of you, What do you think is the evolution? What have you seen happen? How have you been fabricating these? I've known you for quite a while. We've been grateful to have you on a number of our projects. What do you think is going to be the evolution? How do you think it's been going, and what do you think is the next direction we're going into?
Well, I have to say that, Miami is a unique environment. It's everybody wants to see and be seen. You have architects. We have the Miami 21, which provides the code that requires you to screen garages, and it provides the architectural canvas for architects such as yourself to give them creative license to do something really spectacular. So you often see the mundane garages where people are just trying to meet the minimums, but there's always exceptions to that. You see people just going above and beyond. The facades that I see Ms. Goldman involved in, they're spectacular. We worked on Collins Park Garage with Alan Schulman. They're just, there's no end in sight, really. The limitations, the only limitation is the creativity of the imagination.
Alan, where do you think we're going? What do you see this screening in our tropical weather historically, where we've been and potentially where we'll be in the near future? What do you think about these shading elements and spaces that we create, the three-dimensionality? Not everybody is from Virginia Tech here who has the ability to understand these kind of complicated things. But tell me, what are your thoughts about it?
Well, I mean, first of all, like Jessica, I feel obsessed. I'm kind of obsessed by the relationship between architecture, local placemaking, local traditions, urban design. And so for me, these kind of projects like the Collins Park Garage help bring a lot of these things together. Yes, I think, we live in a very particular climate here. We're in a tropical climate. And sun protection and design which helps breezes flow through the building are a really important part of design, a part of design that's been overlooked for many years. Strangely, it's in the realm of the garage where we see the attention to this thing coming back. But yeah, we were able to work with City of Miami Beach and Vic and Jason on this garage project. It's a garage project that had a history. It had been flowing around. It was a Zaha Hadid project for some years before this. And when it came back, it came back as a way of helping add something to this community besides cars. It had to do with reinforcing local identity, with correcting some of the urban issues that we had here. There was an area of a lot of empty parking lots that had been empty for 20 or 30 years. And the idea of creating a metal skin to screen the cars, yes, but also to show the possibilities of metal or ceramic skin architecture was really a powerful incentive here. Now, from there, to make it real, it took a lot of work. It is really hard. Yeah. I mean, it was a lot of meetings. We had so many, I don't think we got paid for all those meetings, but we had so many meetings to, for instance, in ventilating a garage, you have to provide a certain amount of airflow. You have to basically demonstrate the airflow through the building. We had to do that by proving that we had enough holes in that facade, but we were also trying to keep the facade material to not have too many holes or too large holes. I can't begin to describe how many meetings we had over these kind of questions, and then basically designing this facade, which basically was a facade that used a bit the semiology of Miami Beach, bringing words that mean something back into the city and onto the facade. And this is the result of a long process. But where it's going, I personally hope that we go more in this direction, that facade design, which maybe now comes under the realm of responding to design review boards and that sort of thing, but that it becomes part of just everyday local practice here. We can talk about that more if you like.
You know, what you said about the ventilation is a really interesting point. When we were dealing with the development of the Wynwood Garage, you know, which has a very unique treatment on the facade, one of the challenges that we had was, in order to get the ventilation, the amount of perforation that we were going to have to put in the facade was going to damage the artistic design. So we had a long, hard discussion, and the developer thankfully said, we'll spend the extra money, and we had to put a mechanical ventilation system into the building.
Right.
And that created, of course, a chain reaction of other design changes, electrical changes, where are we going to put the fans, how's that all going to fit in? But ultimately, I think that we created something just amazing. And you know, I remember that in the early design, there was a concept where the solid panels were going to be graffiti art. And I remember Marlo telling me that you guys thought it was just so beautiful the way it was that you just wanted to leave it that way for a while.
So, you know, it took 4 architects and like exploring kind of what we were going to do here. It took us 4 tries to get to the architect that we felt really, really understood what we wanted to do and really listened, really walked the streets, really kind of gathered all of the information. It was an excellent listener, Tom Falders out of San Francisco. And, you know, because all of the other architects had proposed things that felt like they were dropped out of outer space, you know, that they belonged in Disney World and that they didn't feel kind of authentic to the neighborhood. But the neighborhood didn't really have a lot of architecture, so we were kind of creating the vocabulary of the neighborhood. And so when we got to that point, you know, as a developer, as, you know, and my dad never liked the term developer. We called ourselves romantic developers. But at the time, you know, we decided that once we had a plan, the importance of marrying not just to the project, but to the people that work on the project. That I always say to my team, I said, give me an award-winning project. Give me an award-winning, you know, building or garage. Give me something that you in your own industry will be so incredibly proud of, that not just for me to be proud of, but that Vic will be proud of and that the architect will be proud of. And so I like to be everyone's favorite client, you know, but doing something like this takes a lot of commitment. And I think not all developers understand that. And so in a lot of cases, some developers need to be kind of shepherded along and encouraged and educated about the fact that something like this is actually really good for business. It doesn't just cost money to do it, but the benefits, you know, this is an incredibly successful garage, and I remember very specifically at the time we were like going into the ground, people were like, people are not going to use cars anymore. Why are you building a garage? And so I'm like, you know what? I still believe that Miami is a very vehicular city. We need more walking, but the truth of the matter is that in the time that it's taken from you know, inception to now, we've been a couple of years, nothing, I don't want to say nothing has changed, a lot has changed, but you know, there's still a need for garage. And so at least if you're going to do something that has a positive influence on the communities where you're building, that elevates the quality of life for the people in those neighborhoods. I don't know any other place where people stand on the street corner and take pictures of this building, you know? And a lot of our challenge was that people didn't even know this was a garage, right? In the very beginning, they had no idea it was a garage. They thought maybe it's an office building, maybe it's just some cool museum. So anyway, that's that.
No, that's very well taken. If you look, for example, at the Moxie that we did in Miami Beach, that is a screening project that Jason and company did. And it really is a complement and a DNA of what the historic district is.
Absolutely.
In Miami Beach. So the Moxie, which is a hotel, and they were trying to revive the district on Washington Avenue, the screening that was done in sight to the DNA of the Miami Historic District as a complement. So the city looked at that screening as a big asset. If you go to Gateway, for example, in Wynwood, like Jessica said, the inspiration of the district, that's the next images on Gateway, are those colorful fabric little samples. That's it. You see the Wynwood inspiration of the graphics and the artists, and it was actually allows for the ventilation in the garage due to the fabric being a screen. So screens can be fabric, they can be metal, they can be laser cut, they can be various materials, and like Alan said, that's what makes it inspirational. When you look at what Vic is doing now at the entry to Miami Beach, what is that, Mount Sinai?
Mount Sinai, that's already open.
Mount Sinai, it's nice. And if you go to the next image, you can see the close-up and the amount of detail and thought process that you have to take into that kind of construction. What Jason does on a daily basis, for me, is just incredible. I mean, Vic is nice, and it's great to have a client such as Jessica. I mean, she wears diamond studs on her boots that's going to kick your ass. But, as an architect or a contractor or a vendor and supplier, that's really what we inspire to do. We look for the hard elements to do. Larry in the crowd will tell you, we are lucky to be here in the tropics, next image, is that you have an opportunity, next image, to really come up with ideas and thoughts. Next one, I think, boom. Again, Wynwood, the screen can be nothing more than just a beautiful mural, right? Next image, you can get that inspiration, and it's a very interesting facade for our buildings. Jason is working on a couple of very unique projects right now for us, which we're not going to talk about, but it's amazing what is becoming in our tropics here. Does anybody have anything else to add? Because we need to give people Q&A sometime. So I just want to make sure I'm being respectful.
I think I'd like to...
Go ahead.
Sorry, I was just going to say, isn't it strange that we're showing so many garages here? I mean, a lot has been written about this idea of the art garage in Miami, the kind of design garage. But it is the place where we can do things. It is the place where we can curate. It's harder on a facade, and certainly we've all probably been through these situations where you think about adding, like there's a few projects I show here, where we add a screen to a facade of windows, and somehow, that's two facade systems, and then when it comes to value engineering, something, it gets challenged, right? It's harder to fight. The garage, and sometimes even in the blank wall, so this is the Soho where we did a screen down the center, but somehow the garage is this unchallenged world where we know we need, actually code requires that we need a screen, but so we have to do the screen. So all of a sudden there's an opportunity that is opened up. But I do hope that it points to other, and I really think that, I appreciate what you're doing in Wynwood, because I think, it is not about just the garage, it's about every building. You have to think about the curatorial process, how it applies to many different types of facades, right? But I think that might be a lesson for all of us as well, like that we need to somehow bring that logic into the everyday building, into the everyday facade as well, right?
And I would encourage all of the architects to think of art in the beginning of the process, not as an afterthought. Not as like, oh, here's some open space, we could put a little something over here, or we just put a little something over there. Like, it needs to be thought of just the way you think of, the plumbing and the electrical and all of that right in the very beginning, because that will make for a holistic project that is a really, really beautiful project versus, I mean, I can't tell you the amount of times that, you know, I've seen projects and, you know, not ours, but where at the very end, they're like, oh, we need to put art. And, you know, and they're trying to find little nooks and crannies to put them. And then it's not authentic. It's just not authentic. It's not really embracing the whole kind of concept of art, things that are artistic and creative. And so the good news is that, you know, things that we've been doing for a long time and things that as a city, like sitting here and watching all of the projects, like we should actually as a city get an award because we have, I think, some of the most beautiful and interesting garages of any place I've certainly ever seen. And so, but as a result of all of this and as a result of kind of the leadership of our city in leading by example in our projects, I think that the whole concept of infusing art into real estate is kind of catching on wildfire. I think it's not catching, it's spreading like wildfire. And so what was natural to us now has become like, oh, that's like a good idea, and that's kind of becoming expected. So I think we've changed the discussion. So I think it's much more understandable and much more embraced by the architectural world, by the developer world. So I think that's a really great thing.
100%. And it creates a value. The designs 100%. And the creativity creates a value that arguably would not exist otherwise.
You know, one thing I did want to say is that the garage is really becoming like a facilitating medium because with few exceptions, you know, like when I started my career and we built the garage, it was a gray box. That's all they wanted. And if you drive around the county and you see the Metro Rail station parking garages, and you know, they don't weather well, they're not attracting traffic. Most of these projects are really mixed-use projects with a large parking component. And you know, like when you're looking at their museum garage, has 30,000 feet of retail in the design district where they've really done a great job of promoting foot traffic, which is essential to the success of that component. You know, when we built the Pennsylvania parking garage for the New World Symphony, that has a retail component. The design team gave the city a lot of suggestions about how that retail component needed to be developed to make it successful, and the city didn't listen, and that particular retail component has not done well. But then you go to other projects that we've done, as for example, in the Wynwood garage, not to beat it to death, but you know, that's actually a great example of how the collaboration on the front end is so important. When we started working on that project, if you recall, you had an office component wing. That building kind of has like a short leg on it.
Yep.
And when we ran the budgets, it was coming in very expensive, and we threw out an idea that why don't we just put all the offices up on top? And that's going to help us with a lot of utility stuff. And we actually ended up with a great office space on the roof level that it's like 30,000 feet, I think.
Yes.
And you got an amazing tenant up there with incredible views of the city. And so it's not just a parking garage. It's a mixed-use project which is providing parking for its needs as well as for the community's other needs.
Even the parking is arguably a temporary use, right? I mean, you're right, the city needs a garage now, but it's space. In the future, it could become something else. We don't know.
But the worst garages in the world are ones with really low ceilings, and they're really dark, and they're really hard to maneuver. And so, you know, you have to kind of make the decision, like, am I going to be generous with our space? You know, we might have fewer spaces, but, you know, but it's a better experience. Like, what is the customer experience? What is the experience from the outside looking in? What is the experience from the inside looking out? You know, and if you are customer-centric, then that's kind of how you need and want to think.
Becomes a celebration of arrival.
Exactly.
Any questions? Perfect. I love it. No questions. I love it.
They're hungry.
That's good.
Very good. So if there is no questions, let's give him a hand. Come on, that was a highlight.
You want a question?
Thank you very much.
There's one question.
There is a question.
One question.
I would just like to make a comment about what we are doing. We are all somehow involved into construction or designing. And civilizations that came before us had different motivations and reasons to create the buildings they made. Now we have taken this responsibility into bringing in our own terms the pieces of the things that we're going to build as our legacy. You know, we can make things that are profitable, that are really important for business, and that's the reason probably that originated everything. But in the end, what we leave, what we create, is actually what is going to have more value than everything. So our responsibility, what we are doing today, is really big.
Thank you.
It has to pencil out, but it's your legacy, right?
It's a legacy.
It's your legacy.
And I think that that's the biggest value of them all, because it transcends. It motivates, it makes other people to improve and have a better lifestyle or a better way to see life.
Absolutely. Thank you.
Thank you.
Thank you. Thank you.
Okay, great. So I would ask you guys to stay because we will be doing now the plaque ceremony. The rest of you, except for the speakers of this session, please stay in the room. The rest of you are dismissed for lunch. And we'll see you afterwards.
And you'll see the tower massing also has these really nice massing cuts at the corners. And this is only because we really want to make sure that the outdoor spaces are all viewing this sort of important view corridors of Miami. So since this project is designed post-COVID, we really want to make sure that we're embracing nature and wellness in the design. And we've done a lot of in-house studies using AI tools and UI analysis. We were looking at the shortcomings and the advantages of the site, and we realized that it's pretty hot and humid all year round here in Miami, but if we can harvest wind flow, you know, it goes from 19% to 52% comfort for people in the building. So we really want to coin our tower as a breathable tower. We're going to have operable windows, we're going to have natural ventilation, and also the balconies are positioned at opposite corners of each other, so we're really going to encourage cross-ventilation. And of course, window-wall ratio is all the rage these days, so we're not going to just be irresponsible, design an all-glass tower, so there's going to be a lot more solidity than what we're used to. You'll see from this axon, there's really nothing of this sort of scale around the area, so when we did the view rows analysis, it's pretty clear early on that you're going to have spectacular views starting from 100 feet and over. So standing at 640 feet tall, this is really going to be an amazing landmark in the area, and also it will serve as a gateway to also the 3 neighborhoods and also Miami Beach. Let me talk a little bit about the podium, because we really want to make sure that the tower and podium concepts are similar. We started with a straight extrusion because there's a lot of parking spaces that we need to fit within the box. But we've also chamfered the corners to allow for these sort of special moments where it reveals the retail, reveals some outdoor spaces. But if you look closely, it's really the tower massing rotated 90 degrees. So there's a strong correlation between podium and tower. It's not just another tower sitting on top of a podium. And then we've also added these special facade openings throughout the entire facade. We were thinking that it could be advertisement, it could be windows to the restaurant that's behind the podium facade, but most likely we would hope that it would be some sort of murals done by local artists. So there's always a dialogue between the building and the city when you're passing by. Since this is designed post-COVID, a lot of our efforts were put into how to lure people back to the office space. So it's amenity rich and it's hospitality driven. And you'll see throughout the entire building, there's a lot of different amenities sprinkled from the ground floor all the way to the rooftop. I'll start with the ground floor experience. If you know the site well, you know that we're next to a highway, we're next to two pretty heavily trafficked streets. So what we did differently is that we're placing retail along the two streets to activate the ground plane experience. But what we're doing differently is that we sort of want to create this sort of exclusive access for people who are working in the building. So what we did is at the northwest corner, there's a little portal allowing people to drive in or walk in to work in the building. You'll see very fast that the look and feel of this portal is very different from the facade itself. The facade is bright, shiny, happy, but once you enter the portal, it's dark, luxurious, quiet, and serene. And the motif of that palm tree is actually repeated everywhere in the building. So you'll see this light bronze ceiling soffit with this palm leaf imprinted on top as a relief. Once you enter the building, there's going to be a 4-story courtyard that opens to the sky. And this courtyard is surrounded by this lush green facade, hiding the parking garage behind it. We think it's very important to create this hidden oasis so that when you enter the building, it's quiet, it's formal, it's serene, and when you enter, you realize, well, what a great day to come into the office. So moving on to the podium rooftop, there's going to be a special restaurant, and it'll be housed in a little 2-story glass pavilion, and then there'll be outdoor lounge and bar, and of course, a variety of amenities such as conference rooms, co-working space, gym, spa, and also an outdoor pool overlooking Biscayne Bay on the east side. Moving on to the rooftop, on the 47th floor, there's going to be a double-height sky living room, so this will be a really nice lounge for people who are working in the building. It's going to have great views of downtown, great views of Biscayne Bay, and a place to really relax. And then, of course, a sky garden at the very rooftop. We imagine this will be an open-air, naturally ventilated outdoor terrace or rooftop garden, and it'll be beautifully landscaped with a little walking path where you can have walking meetings. Okay, on to everyone's favorite topic, facades. So, our project is really inspired by nature. So we really thought palm leaves is actually a really nice motif for the entire project, and especially for the podium garage. What we really like is that sinuous curvilinear shape of palm leaves, and we kind of apply it to the garage in these thin stripes. And you'll see that in the garage facade, there's this little dimple that we introduced to allow for more airflow. We really want to make sure that this garage is really nicely well ventilated when you enter. But for the tower facade, the challenge is a little different. We spend a lot of time balancing two things. We know we need to get to a high window-to-wall ratio, but we also don't want to sacrifice views from the inside. So we look at different designs of fins, horizontal, vertical, wider fins, deeper fins. We sort of arrived at this shape, and a ratio of 45 wall, 55% window. And this sort of inverse trapezoid shape is actually kind of interesting because it doesn't really sacrifice views from the inside because the widest portion is actually at the spandrel zone. And the narrowest portion closer to the ground, the floor, it's only 8 inches, so it creates this nice organic pattern from the outside without sacrificing any views from the inside. So that's a curtain wall module of 5 feet wide, but you can see the thinnest portion is 8 inches, but at the top, we're looking at something around 1.6 feet. So still a really spectacular view looking from the inside of the building. And because it's an office tower, we really want to make sure that the amount of outdoor spaces are pretty similar. So there are some instances where balconies are actually hidden behind the screen wall. And we've taken an opportunity to take out the glass panels, so natural ventilation is everywhere on this balcony. And of course, views from the balcony, great access to views, natural air, and just an amazing place to work. And so there's 2 balconies per floor. And we think this actually really redefines workplace of Miami. This project has been a year-long collaboration with Kevin Vanger and his team from 1000 Group. And us at KPF are really excited to be part of this process. And so we just can't wait for this building to get off the ground. Thank you.
So looks like we are done already with this presentation. How is that possible? Did you guys enjoy it? Was it any good? Yeah, so let's say thank you, Grace. Good job to be done on time. So the next one is actually a topic that is really, really critical for this marketplace, and that is the process of certification for the impact-rated glazing systems. And in this market, there is a number of people doing it, but there is one authority, and that's Al-Farooq. So without any further ado, I would like to introduce Jalal Farooq here to give us an insight into the certification process.
Thank you. Thank you so much. Yeah, so, several people earlier today talked about NOAs, Florida approvals, impact-rated products. I was hoping today I could spend a little bit of time talking about what exactly happens in order to get an NOA. What are the differences between some of the different certification methods? And what do you do once you have all of that? So really, I would say getting a hurricane-rated certification comes down to 3 main steps. The first step is to do some kind of a design review of the system that you have, creating a testing program, and then putting it all together once the testing is complete with some kinds of calculations and a set of design drawings. So the first step is to do some kind of design review, either with an engineering firm or internally, but you have to kind of decide what it is you want to get out of the system that you have. I would say a good rule of thumb is, 80% of the things you want to try to do, that's what you should try to certify. But then, looking at what it is you want to qualify, you have to determine whether your system, is gonna meet that or not. You could be aiming for the stars, but your system is a very low, a light system, let's say. So part of our design review process is determining what those goals are, matching the system performance to those goals, and then making some kind of suggestions in terms of strengthening your systems or adding reinforcing or looking at certain design elements of the system itself. Once we've gotten through looking at the system and matching goals to estimated performance, someone has to create a testing program for you, and essentially that's 3 things. It's instructions for the system provider on what to build, instructions for the testing laboratory on what to do with all of the samples that they receive, and kind of an explanation of what you're going to get out of all of this, assuming, of course, that you pass all of the testing that you're doing. You don't want to think you're going to get one thing, do a ton of testing, spend a ton of money, and then not get that thing. Here's just an example of a impact test. This is for level D, and I'll talk more about the different missile levels later. So in Florida, there are essentially 3 different certification routes you can go with, either through Miami-Dade, which has the Notice of Acceptance, or the NOA. That's probably the one that's the most known. The one-time approval, which is also through Miami-Dade County, and Florida product approval. They're all kind of competitors to each other, I would say, and we'll go through kind of the differences between each one of them. The first and most notable difference is that for Florida approvals, it's really more of an administrative review process, whereas with an NOA or a one-time approval, there is a technical review process that basically the county is going to review your calculations, your test reports, everything. Whereas again, it's more, you're relying more on just the consultant that you're working with initially for a Florida approval. Another important distinction here is that with Florida approvals, you can submit both high-velocity hurricane zone rated or non-high-velocity hurricane zone rated applications, whereas with an NOA or an OTA, you can only submit HVHZ rated applications. Another thing regarding the fee schedule here is that at a glance, it may look like Florida approvals are a lot cheaper, but the cost is really comparable between a Florida approval or an NOA, since while an NOA has kind of a higher fee, it includes more things. The one-time approval, of course, is an hourly review process. And one other thing is that if you're looking to certify a railing type of system, that's only available through Miami-Dade County. So there are really 4 different certification schemes that you can go for in the context of a hurricane-rated product. You can either have it be rated for high-velocity hurricane zones or not, and you can have it rated for large missile or small missile. Within large missile, there are essentially 2 main categories. That's going to be level D, which is your standard application, and level E, which is for essential facilities. You're going to be using large missile for the first 30 feet of the building, and small missile for anything above the first 30 feet. So just to go into the differences between HVHZ and non-HVHZ rated products and some of the differences between, just to begin with, HVHZ in Florida is defined specifically as Miami-Dade and Broward counties. So anything outside of that is technically non-HVHZ, although a lot of counties like West Palm Beach, for example, still often the expectation is that you have an HVHZ rated product in somewhere like in Palm Beach. You can use an HVHZ rated product anywhere in the state of Florida, but a non-HVHZ rated product can be used anywhere in Florida except Miami-Dade and Broward counties. Another important distinction, and that was mentioned before in an earlier topic, was non-HVHZ rated testing is following ASTM 1886, 1996, and ASTM E330, whereas HVHZ rated testing follows TAS 202, 201, and 203. That would be the most analogous thing. And there are some differences in things like the deflection limits, which is L over 180 for HVHZ, but L over 175 for non-HVHZ. Another really important difference between the testing schemes is that while HVHZ rated products have kind of I would say a stricter testing sequence, non-HVHZ or ASTM 1886, 1996 based testing is going to be more strict in terms of the substitution criteria. And so when you're building a product which has a lot of variations, what ends up happening a lot of times is you could end up actually testing less with an HVHZ rated product than with a non-HVHZ rated product, just because it allows you to do those initial substitutions right away, whereas with non-HVHZ you start with some initial set of specimens and then build your variations off of that. Another important difference between the two is that there are additional impacts to glass and the frame with an HVHZ rated product versus not. Just to talk about some of the differences between LMI and SMI, as I mentioned before, LMI is going to be for your first 30 feet of the building, and SMI is going to be anything other than that. You can use an LMI rated product anywhere in the building, including in SMI applications, but the reverse is not true. If you have an SMI rated product, you cannot use that in the first 30 feet. And then of course, why do both? Why, if you can use an LMI rated product throughout the whole building, do you also qualify products for SMI? Well, it's because if you have, let's say, I don't know, a 20-story building, your first 3 stories are going to be requiring LMI, and the other 17 only need SMI. And when you have an SMI rated product, it usually is going to be using a lighter interlayer or less amount of interlayer, so it makes it worth it to test both things. This section is kind of for people, I would say, who are newer to the Florida market. And these are things that I see people just kind of mess up all the time, especially if they're not as experienced in this market. And the first thing that people think a lot of the time is that, well, I don't have any testing, I don't have anything certified, I have a product here or a project here that I need to get things going with, I don't have time to do all of this testing and certification. What about a one-time approval? I heard that that's something that I can get. Well, a one-time approval is not really the silver bullet that I think a lot of people think it is going to be. It's really going to be more for, I have something certified or have something tested, I need to get a little bit more performance out of it, I need 10%, 15%, 20% more. You know, that's what an OTA is going to be for. It's not going to get you out of jail when you have nothing to start with. Another thing that we see from time to time is people will come with testing from different laboratories, and the testing that they've performed is not from an accredited laboratory or one that is accredited by the state of Florida or by Miami-Dade to do those specific tests. And you know, it's a shame if you do all of this testing and you've gone to a laboratory that may be accredited for this testing in New York or California or something, but you have to completely redo all of it because you didn't go to a laboratory that's approved in the state of Florida. Another, I guess, crucial concept to understand is just because you pass testing for a certain size, a certain load, a certain configuration, does not mean you're going to actually get that thing certified. Because when you are creating a certification in Florida through Miami-Dade or through the state, your certification is going to be the resultant of whatever you have tested and whatever you can prove by calculation. Whatever's the worst out of those things is what you get. So even if you test, I don't know, let's say a fixed window 5 by 10 to 100 PSF. But if based on ASTM E1300 you only get 80 PSF, then for that size you're only going to get 80 PSF, even if during the test you passed at 100. Another small note here, specific to HVAC, is that when you're testing the product, it will need to be tested to ANSI Z97.1 when the product is going to be used as a guard inside of the frame that it's actually going in. Another common issue that is overlooked, I would say, is particularly in like the earlier design development process, is that in HVAC rated applications specifically, when you have an SSG rated product or an SSG product, your tension is going to be limited to only 20 PSI. You know, a lot of times you'll see people using something like 30 or whatever the ultimate tension is divided by 5. It is written specifically in the Florida Building Code for HVAC rated applications that you're limited to 20 PSI. Another thing is when people are testing, they may take certain liberties of changing around their testing program a little bit without talking to their consultant, and this can be a huge mistake because you may not realize it, but very small changes in the testing that you're doing can have a huge effect on what you actually get certified in the end. So if you're going to make changes, definitely talk to your consultant and make sure that that change that you're making is not going to affect any other part of your certification. Another thing that I see all the time, that particularly system providers who are coming to Florida for the first time, is that they're trying to get everything done at one time. They're trying to, you know, they think it's going to take so long to get their product certified, to get through all of the testing. They don't want to have to do this in multiple rounds. And that's usually a pretty big mistake too, because, you know, your first time you're doing this, you're learning, you're going to make mistakes, and if you try to do everything at once, I just see it all the time, you just get overwhelmed with everything that you have to do, and it ends up being worse than if you had just done this more gradually. So I was talking mostly about Florida, but what about outside of Florida? Well, outside of Florida, it's kind of the same concept, but you know, instead of Florida approvals or an NOA, there are several national accreditation agencies that can create a listing for you. This would be somebody like AMA, Keystone, WDMA, and they'll create a certificate explaining what sizes you have approved, what dimensions, what configurations, and so forth. Another thing you can do is just submit a test report and calculations. You're probably used to that in some capacity. Another thing you can try to do for impact-rated products is submit your Florida approvals or your NOAs to the local jurisdiction. They're not required to accept that, but they pretty much always do. You know, most people recognize that Florida has one of the strictest certification processes out there, and if you provide them with that evidence, it's usually sufficient. Specific for Texas, which is the only other state that has its own hurricane certification program, they have their own program that you can apply through, but they also now have a direct route for acceptance of your Florida approvals or NOAs. So essentially, if you have a Florida approval or an NOA, you can basically fill out some paperwork and they will cross-list that certification on their website as well. So putting it all together, now you have tested your product, you've certified it, it's either HVAC or non-HVAC, it has certain approved dimensions, and a certain approved missile level, approved hardware, glass build, anchors, etc. And to get a permit with this, it's like any other project. You are going to create a shop drawing, calculate your wind loads, and then in order to show compliance with your project, assuming that everything in your project is within what you have certified, all you're really going to have to do is just highlight all of the relevant portions of your product approval, either your NOA or your Florida approval, to show compliance, showing what glazing you're going to be using, what pressure it's approved for, what size it's approved for, and that's really all you have to do. Now, if you have conditions outside of your product approval that are on your project, then you will have to submit calculations to the city or the local jurisdiction, and it's going to be up to them on whether they approve it or not. Finally, I'm just going to talk a little bit about a new and upcoming ISO standard for hurricane glazing that I was lucky enough to be invited as the North American expert to help create. And I've already talked about the differences between ASTM and TAS, but the ISO standard for hurricane glazing or hurricane testing is based primarily on ASTM 1886-1996. But with certain elements of the TAS testing in there, for example, the test procedure is very similar to what's described in ASTM, but the substitution criteria is more based on our traditional understanding from TAS. It's designed to be friendly for people who have already tested based on ASTM or TAS, so that there's a minimal amount of retesting or additional testing that's going to be required. One new element to this ISO standard is that, traditionally for both ASTM or TAS, you're going to be limited based on the maximum dimension that you have tested for a certain product. Now, that's still true with this new ISO standard. However, you're also going to be limited to being only half as large as the smallest unit you have tested, as in terms of what your minimum size can be. And that's just something new. So if you have a very small unit that you're trying to create, you are going to have to test a smaller unit as well. And that's it. Thank you very much.
Jalal, thank you very much. That was very insightful. So the next topic is the art and science of, and psychology of daylighting and designing with glass by Zak Redden from ES Windows. And by the way, ES Windows is the company that I was referring to as the only player in town.
Thank you, I wasn't sure about that. Good afternoon, everyone. Having fun? My name is Zak Redden. I'm the Director of Architectural Sales for ES Windows. When my marketing department reached out on this event about a month ago, they said, would you be interested in presenting? I said, absolutely. I love to hear my own voice, sure. What are the rules? There are no rules. You can present whenever you want. So I was like, well, can I get into poker theory and game theory? I like to play at the World Series of Poker. Look, it has to be about Windows. So the topic I came up with is kind of along the lines of my background in psychology. So as this gentleman said, it's called The Art and Science of Psychology, Daylighting and Designing with Glass. So we will get into it. And I need to be on my best behavior because we have a mixed group here. Usually when I'm presenting to architects, I make jokes at the GC's expense. But when I'm presenting to GCs, I make jokes about the architects. So just show of hands, how many are on the design side here? All right. How many are on the construction side? All right, I got to behave. So we got a good mix on both there. You guys are a tough crowd, by the way. Jeez. So like I said, I'm Zak with ES Windows. For those of you that are not familiar with ES, here in Miami, as you alluded to, a lot of folks know about ES. where I'm from in Orlando, and certainly that I-4 corridor north, not many folks know about us. But down here, we got a pretty good brand name reputation. For those of you that don't know about ES Windows, we're part of the Technoglass group. This is an aerial shot of our facility down in Barranquilla, Colombia. It's a massive campus, just to kind of give you a sense of the size and scope there. That's a baseball field. So we have over 4 million square feet spread out over these 12 different buildings. And we're kind of unique in the fenestration industry in that we are fully vertically integrated both on the glass side as well as on the extrusion side. So our sister company, Technoglass, who's also our parent company, is our glass supplier. We fabricate all of our own glass in-house. Likewise with our sister company, Aleutians, we have a foundry on site. We're pushing our own extrusions. We're painting those extrusions up to 2605 performance standards, up to 20-year warranties, et cetera. And then ES Windows is kind of the actual pre-glazed packages, these pre-glazed curtain wall panels, window wall panels, sliding glass doors, et cetera, that actually come into the market and have product approvals. So just a quick little high-level overview of the agenda. It's really going to focus on daylighting components and associated health benefits to consistent exposure that we as humans have when we come in contact with natural sunlight. We're also going to touch on ways to control the sun's energy that it's throwing at us through some of the technologies that's available in the market. We'll spend a little bit of time talking about kind of some best practices. We'll even reference some LEED standards for those of you that develop projects looking for LEED certification. Even if you're not developing a product for LEED certification, I think you'll get some good design strategies as best practices to possibly utilize as far as creating views to the exterior and daylighting significant portions of the interior. And bullet number 4 is a fun one because I think in general, except for ES marketing, because our marketing team is amazing, but in general, I think the fenestration industry in general is not doing a good enough job of making windows and doors and glass sexy. And what I mean by that is, somebody made a joke that budgets in South Florida are too low. Well, I don't disagree with that, but I would say window budgets in South Florida are too low because all of the interior designers are stealing those budget dollars for, exotic flooring, countertops, cabinets, $8,000 Waterstone faucets, lighting fixtures. So we need to reallocate some of those interior dollars over to the exterior glazing. Any interior designers here? All right, no offense, but you guys are gobbling up the budget. We want some of those budget dollars back for the exterior facade. So we'll talk about some of the ways that we're hopefully going to make windows and doors and glass sexy for you guys and you guys for your clients with different aesthetic options that are available, and then we'll wrap it up with some product examples articulating these. So we'll start off with kind of a basic definition of what daylighting is. It's the introduction of ambient exterior light into the interior of a building. Obviously, the primary exterior building facade material to utilize that and get that light in is glass. Visible light passes through glass, so that's our primary way of getting that light into the interior of these buildings that we live and work in. It can be intended for a specific purpose or just to enhance the quality of interior spaces. We break it down into 2 general components: sunlight, which is direct from the sun, typically through floor-to-floor glazing, versus skylight, which is more diffuse, which is typically coming through higher type windows, etc. Of these 2, sunlight is potentially more susceptible to glare, which we'll talk about some strategies to mitigate that, whereas skylight is more diffuse and not as susceptible to glare. So again, to kind of go back to my psychology background, I've always been fascinated by human behavior and just our mood and why we do what we do. So at the root of psychology is usually physiology. So some pretty cool things happen at a physiological level when human beings are exposed to natural sunlight. And we're going to get into some of this stuff. One of them is it actually triggers the release of endorphins, which is a natural mood enhancer, makes us feel happy. If you're familiar with the acronym SADS, it's called seasonal affective disorder. It's also known as winter depression. Historically, it was only prevalent in northern latitudes where sometimes during the winter the sun wouldn't get up above the horizon very much. And because of that lack of sunlight, people would be, experience these symptoms and basically have a winter-type depression. We've actually seen that northern geography trickle down to southern latitudes, especially for folks that work in buildings that don't have proper views to the exterior or consistent exposure to daylight. So I think the Miami Curtainwall team, who did a phenomenal presentation this morning, referenced buildings in the 70s that were built with very small or few windows. So imagine, and apologies to any government workers here, imagine you're you're going to a 9 to 5 in Broward County, working for Broward County Sheriff's Office or something, and the building's been built in 1975, has very small windows. There's a lot of the day that you're not getting natural exposure to sunlight versus some folks that work in more modern offices where that daylight's coming through. So you may be more susceptible to this and not even know it. So one way that we can avoid this is to get consistent exposure to daylighting. Another benefit here, not to get too much into the weeds, it does, sunlight activates vitamin K and vitamin D, so it's very, very important in growing children to develop strong bones, etc. And the last benefit we'll talk about really has to do with our circadian rhythm and kind of regulating our internal biological clock. So we kind of have this incredible waxing and waning, this balance of neurotransmitters and hormones going on in our body as it relates to exposure to daylight. So if you're familiar with melatonin, it's known as the sleep hormone. When we as humans are exposed to sunlight, it actually suppresses the secretion of melatonin. So the net effect is that during the daylight hours, we feel more alert. On the contrast side with serotonin, which is the neurotransmitter, it kind of has the opposite effect. So these two neurotransmitters and hormones kind of play a balancing effect and keep our biological clock and circadian rhythm resetting itself every day so that we sleep better at night and then we're more alert during the day. There's a wealth of psychosocial studies that have been done to show that buildings that have proper daylighting strategies, humans perform better, whether that's in an office environment as a worker, whether that's in a classroom environment as a student taking a test, or whether that's my wife at Target buying retail. So happy individuals tend to spend more money in retail, do better on tests, and be more productive in the office. So it's not surprising that LEED has recognized the benefits of daylighting to these buildings that you guys are designing and building, and allows us to garner points towards LEED certification on these by utilizing proper daylighting strategies. So I'm not going to go through all these just because we only have a short amount of time, but I really want to focus in on credit number 8.1 and 8.2 because they're very much linked as far as indoor environmental quality credit. With 8.1, we're talking about trying to daylight 75% of your interior spaces. We can utilize that depending on the floor plate, possibly utilizing high windows with light shelves on the interior to bounce light off and reflect it further back into the cavities of the buildings. 8.2 means that we want to have a connection, a visual connection with 90% of the area so folks can actually look out and see the outside world. Both of those are related and should be considered when you're designing these buildings. So we've been talking about the visible light, which is about 380 nanometers to 760 nanometers, give or take. But the sun, which we love and know, is throwing a lot of energy at Earth. Thankfully, our atmosphere is screening out some of the stuff like gamma rays and X-rays, stuff that we don't want to deal with. But UV, infrared, that stuff gets down to the surface along with the visible portion. So the challenge for us as window and door manufacturers and for you guys as specifiers and folks that want to build energy efficient homes is how do we take advantage of the benefits of daylight by using more glass and inviting that daylight in to create happier occupants, but not do so with a thermal penalty. So I'm going to show you how. So one of the ways that we can really increase energy efficiency as it relates to daylight is to utilize these low-E coatings, which are kind of a marvel. They're thin metallic oxides that are applied to the surface of the glass, typically on surface number 2, and it spectrally selects different portions of the solar spectrum to weed out while allowing the visible portion to come through. So the net effect of these low-E coatings, especially if it's on a clear glass substrate, is that we're allowing the visible light to pass through and garnering all those benefits for your interior occupants, but we're keeping the UV and infrared out, or most of it out. So it allows for greater window-to-wall ratios without much of a thermal penalty, especially now that energy is relatively cheap versus back in the 70s with the OPEC crisis and stuff. You can also utilize tints. Warm-head spacers certainly can increase your U factors, argon or krypton-filled air spaces, and laminated interlayers. Laminated glass, even when it hasn't been coated by anything or doesn't have a tint, just clear laminated glass is going to screen out about 99% of the UV, which is pretty impressive. So these technological advances really allow us to keep that sun's energy to the exterior while still inviting that light in and allowing some high window-to-wall ratios. So So it's a typical type of facade here. We're starting to see big trends, certainly from the late 70s, 80s into the modern times, where these window-to-wall ratios are growing exponentially, and oftentimes it's 100%. It's just glass facades completely without much of a thermal penalty, because we're still able to keep that solar heat gain down quite low because of these coatings and other technologies that we have here. Just some potential daylighting strategies here to utilize. Obviously on north glazing, you don't need to worry about glare too much, but on southern exposure, especially down here in Miami, you guys know that UV is brutal, that sun is brutal. When it's low in the sky in the east and west, it can potentially cause glare and make interior spaces uncomfortable for students if it's a library or workers in an office situation. So what we recommend here is the judicious use of things like sunshades and light shelves, especially on southern elevations, to shade those interior areas and still bounce light further back into the cavity without, creating too much glare. Also, vertical fins and ceramic frits can be used to reduce glare. This is a good example here of some vertical fins, which aesthetically looks pretty darn cool as well, but it also serves a functional purpose of again, mitigating that glare potential on the interior of this. I actually think the real building looks better than the rendering, which is pretty cool. So depending on your look, I think on this one here it's about 16 inches out, so we have some flexibility with that as well. So we're happy to work with the design teams to design whatever level you want as far as that goes. Ceramic frits and decorative glass is definitely a way for you to build a distinctive exterior for your client. This particular project for USF down in St. Pete had a series of these concentric circles with different opacity, I think 4 or 5 different color gradients. Some built-in benefits as far as bird strike deterrent, but it also helped to reduce glare and create a truly unique exterior facade via these ceramic frits patterns. Now for my favorite part here, the designing with glass. So I mentioned I think the window industry could do a better job of making windows sexy, and we got to get those interior designers to give us some budget dollars back. So this is kind of stuff that you guys think about on the design side, typically to create this unique exterior facade for your client. So what you're thinking about typically in pre-conceptual and pre-design, even in schematic design, you're typically probably thinking high level as far as systems versus more specific specification details. So at this point, you might be trying to weigh the advantages, pros and benefits of curtain wall systems versus window wall systems versus punched openings. If you're going curtain wall, window wall, what type of mullions are you going to utilize, like a structural silicone glaze with a tight butt glaze, which looks really, really sleek and modern, or more captured or kind of a hybrid. If it's punched, you're probably going to be wanting to take advantage of more narrow profiles and more glass just to give those widened views to your clients that are looking out at Biscayne Bay or Miami Beach. Obviously, you want to utilize tints and potential different coatings to create whatever aesthetic look you want for that exterior glass. And then we have all kinds of fun bells and whistles as far as curved glass and digital printing, spandrel, frits, all that stuff, glass railings, interior glass, etc. So window wall systems, very, very common down here in South Florida. You'd be hard pressed to tell me this building here on the left if that was a curtain wall or a window wall. So it's actually a window wall where the system is sliding between the slabs, but we have a spandrel glass slab edge cover to really kind of give you that almost 100% window to wall ratio and almost look like a curtain wall at a bit of a cost savings because it's actually a window wall with a spandrel glass slab edge cover. It's a very popular look here. So this is that SSG mullion, again, becoming very, very popular here, where the mullion is actually set behind the glass. So from the exterior, you have that nice, tight butt glazed look versus the more traditional captured mullion. There's some more window walls as well. This one I actually was not aware until last night. I was coming back from Carrabba's on Flagler that this has some really cool, a little bit of a light show at night, which was kind of interesting. Curtain wall systems, I don't want to get too much into the curtain wall because it's more about light, but this is another option that you guys have. Unlike window walls that are set between the slab edges, these are hung on the outside. So they're a little bit more forgiving, and this is where I normally make a joke about GC and masonry tolerances, but I'm not going to do that today. I'm better than that. Well, you guys are tough. You guys are real tough. But these curtain wall systems do typically allow for greater building movement and masonry tolerances and allows for some vertical and lateral adjustments, etc., unlike window walls. And this is a good example. This is Tampa Airport here. You can see the four-sided captured versus this one over here where we have the four-sided SSG. A lot of people will do the horizontals captured and the verticals SSG. So you can do all four of either or kind of mix and match horizontals and verticals depending on the aesthetic look you want for your client's project or what they're looking for. Yeah, this was an amazing project. Obviously, the Salesforce Tower, very iconic building there. We actually had some integral sunshades incorporated into it, which is kind of cool. We're showing some vertical fins as well. For those of you guys that like to cruise, it's a couple of challenging geographic projects that we did for Norwegian Cruise Line and Royal Caribbean. So the Norwegian one is on the right. Had some curved geometry involved versus the Royal Caribbean, which is more angular and some slope glazing, etc. So next time you're cruising on one of those, think of ES. So big glass sizing, it's all about big sizing, and we're trying to stay ahead of the curve by offering that. We have a whole course on low E coatings, which I'd be happy to come into your office and do a CEU on. I don't want to get too much into the weeds. We already talked about low E and kind of how it does that magical thing where it screens out certain portions of the solar spectrum and allows the daylight through. We broadly break down our glasses, and if you haven't visited our booth, we have 20 different glass samples out there into neutral and reflective. So these run from exterior reflectance, like in the high 40s to the low teens, and everything in between. Different aesthetics, like a silver blue aesthetic, etc. So again, depending on your performance requirements for your client and the aesthetic look they want, we have the perfect glass to fit your budget and your aesthetics and your requirements from a. We also do digital printed glass, etc. Ceramic fritz we talked about. Bent glass, this is some cool stuff. By the way, that's not a real building in case you were wondering. I kind of called BS on my marketing team. I said, I don't see anything structural on that. So no, that's not a real building, but it looks pretty. Number of glass railings, different systems, even spider glass railings, 6 foot tall, 7 foot tall windscreens. A new line that we just launched is our ES Interiors line. This very much dovetails into the daylight theme because one of the best ways to allow daylight to protrude further into these buildings is to use either A, lower partition heights, or B, why not use glass partitions to allow the glass and that sunlight to come further into the cavities and garner more points toward LEED certification. So just quickly to go through some product examples. I think I'm doing okay on time, but you're not going to put the hook out yet, are you? All right, we're gonna wrap it up. So just some project examples, just showing some horizontal fins. This is with a custom curtain wall system. We wanted to showcase some of our capabilities as it relates to curved impact-rated glazing systems. So 830 Brickell, which is not far from here. If you haven't seen it, the northeast elevation is pretty cool. It's all impact-rated, laminated, Miami-Dade product approvals with curved glass, which is kind of cool. Kind of the running joke why they didn't do all 4 corners is because it's so damn expensive, so they had enough in the budget to do 1 corner. Because of the interior designers, again, if they gave us back a little bit, we could have done. It's another cool project. So we have, I think, over 100 different product approvals. That being said, the previous presentation, which was phenomenal, we do a lot of one-time approvals as well. So on this one, we actually built a full-scale mock-up. It's a 34-foot tall custom glass wall lobby, and the client didn't want aluminum mullion. So actually what we came up with was a glass mullion 2¼ inches thick by 14 inches deep. This is the rendering. I need to get some actual pictures, but I'm told it looks even prettier in person. But so we could do custom stuff too. So if you see on our website that you're like, oh, they don't have that, we love to say yes. We don't like to say no. So reach out to us, and we'll see if we can work with you. One of the other trends we're seeing, kind of getting into some tints and aesthetics here, is a lot of these 2-tone different glass colors, sometimes 3-tone. So on this one here, this is a product in my hometown, Orlando, the Tremont Tower, where we used our R3623 on both solar blue and on clear to create kind of a different aesthetic look. A little bit closer here in our backyard, Miami. This is another cool one where we utilize Pacifica blue, pulling the wrong one here, in the central portion with our 3623. Oh, it just froze. Sorry about that. And we used actually That's a typo. It should be 3623 as well on clear, which is on the side portions here. So again, creates a dramatic contrast between the middle portions and side portions. Big fans of Universal Studios. We're actually doing a monster retro right now with 3,000 windows. This is on the new construction side. This is actually clear glass with our N4825. It kind of has a bluish aesthetic to it, even though it's clear glass. So you still get some pretty good visible transmittance in there. And it doesn't create an overly dark interior. And for those of you guys that work in healthcare, we do a lot of custom glass with this as well. This is, again, mixing clear and Azuria with our 4421 coating. Very iconic project on the Miami Skyline. And yeah, I thought that was an amazing presentation again that Miami Curtainwall did. And this is one of those iconic buildings which featured a bunch of different custom products that we did, including a windscreen on that 56th floor around the pool up there. And we're going to fast forward because I think my clock actually went past. But any of you guys doing like historic work and you want to go for that industrial vibe, we can actually create that look as well with custom buttons and stuff like that. So on that note, please come out and visit our booth if you haven't, and I will turn it over to the next presenter. Thank you for your time.
Great, thank you very much, Zak. Our next presentation is about an important aspect of the finishing, which is the environmental and sustainability aspects. I want to invite Winn Darden of AGC Chemical to come up here and start his exciting presentation. Thank you very much. Welcome. This is, by the way, the time. Oh, okay.
So I'm going to talk about environmentally friendly FEVE fluoropolymer resins for powder coatings. That's a mouthful. How many people know the AMA 2605 specification for finishes and coatings? 1, 2, 3, 4. Just 4? Room full of architects, 4 people know? Really? All right. Our products are not a paint. We are the key ingredient that our customers, major paint manufacturers, use to make powder coatings and liquid coatings that meet the AMA 2605 weathering standards. So I have nothing to sell you today. You can't come to me and say, I want to buy your paint. We are the key ingredient for people who formulate these coatings that you can buy. So what are FEVE resins? Well, this is what they are. They're a fluorinated unit called fluoroethylene, and they're a vinyl ether unit, and it's a copolymer of these materials. This structure is key to the performance. The fluorinated segment protects the vinyl ether from degradation by UV light and other environmental materials that will cause damage to the coating. What the vinyl ether allows us to do is it allows us now to make these products that are soluble in solvents. So now we can make a paint out of them. If you think of Teflon, most people familiar with Teflon, very difficult to make a coating with Teflon. It's not soluble in anything. So you can melt it onto a substrate, but that's not something you want to be doing on a building outside, and not easy to do either. The other thing that it does, it adds cross-linking to the polymer. That means we can chemically react our resins with a cross-linker, and we can make a thermoset coating that is not going to be easily damaged by impact and other environmental factors. What are the features of this? Well, outstanding UV resistance. That's what these things bring to the table. So you can do a range of finishes from completely flat to a high gloss. This opens up design possibilities for architects. They're corrosion resistant. While powder coatings are applied in a factory or a plant, there are resins of this type that can be used for field application. That means they can be used to rehabilitate buildings and repaint buildings rather than just new construction. What are the benefits? Well, long-term gloss and color retention. The AMA 2605 spec requires 10 years of South Florida weathering with a certain gloss retention, certain level of gloss retention. No chalking. You're not going to see a haze on the finish of the coating even after 15, 20, 30 years of using these materials. They meet that AMA 2605 standard, and there are other segments to that. There's impact resistance and solvent resistance and things like that. It's a whole series of things, not just weathering. Again, here we can use them for new construction. That's where these would be used on new buildings, or the other types of coatings can be used to rehabilitate and repaint buildings. What are the advantages over liquid PVDF? Most people know PVDF. It's the trade name most people know is Kynar. These are outstanding materials. They've been around for 70 or 80 years now, and they weather extremely well. But in some ways, these FEVE materials are superior to PVDF. There are no solvents in the powder coatings. That means there is no VOCs, there's no CO2 given off during the manufacturing, during the curing of the coating. They can be recycled. You can get an application efficiency greater than 90%, so there's very little waste with these type of materials. Because they're cross-linked, this means they have better mar and scratch resistance. So as they're putting windows or panels into place, there's going to be less ability to damage those, cause dents and scratches on them that have to be repaired. On aluminum substrates, you don't require a primer to get good corrosion resistance with these materials. They have a lower cure temperature, and again, they've got that full range of gloss. The PVDF coatings are limited to about a 30 or 40 gloss reading. These can go all the way up to 90 and all the way down to less than 5. So completely flat versus a high gloss finish. Performance characteristics, well, again, they meet that 2605 standard. No solvents. You can incorporate metallic pigments that have good weatherability with these. Pigment choice is very critical with these, as it is with any coating. You don't want to pick a pigment that's going to degrade rapidly. You want to pick durable pigments that are going to last a long time. These are used single coat applications, and 30+ year life in top coats is possible with these materials. Life cycle, well, fewer recoats mean you use less paint over time. This means you have less waste over time, and that increases the environmental advantages of materials like this. Done some work on looking at carbon footprints, comparing liquid PVDF and the powder FEVE. As you can see over here, oops, wow, I didn't know they did that. The FEVE gives off less CO2 per square meter than the liquid PVDFs will. And again, because you're burning solvent off, that means it's going to be a higher percentage or higher amount of CO2 given off. FEVE powder coatings you can reduce by 25 to 50% compared to liquid PVDF. Higher transfer efficiency, they cure at a little bit lower temperature, and no solvents mean that they have a lower carbon footprint. Where are these used in architectural applications? Well, aluminum windows is a big application for these. Curtain walls, another big application. These are buildings and elements, architectural elements that you don't want to repaint very often. Nobody wants to get up on a water tank and repaint it every 5 years or 10 years because it starts looking bad. And the same thing is true with a building. They've been used on light poles, railings, flag poles, stadium seating, so a whole range of different applications of these materials. Just a few projects to run through. Steinway Tower in New York City. These are primarily going to be curtain wall applications now. 923 Folsom in San Francisco, I believe. Not sure how they're doing there. I hear there's a pretty high office vacancy rate in there. I'm not sure if the same applies for apartments or not. Park Avenue in New York, again, the coating made by AkzoNobel. Uber headquarters in California, same thing, coated with the FEVE powder coating. Another IFS project, mixed-use building in New York City. PNC Towers, these panels here were powder coated with the FEVE resin. It's a mixed development. They use liquid PVDF on the curtain wall for this project. Bulletin building, this is called Schuylkill Yards, a new development in Philadelphia. I think they've taken one of the old newspaper buildings and made it into apartments and offices and things like that. Pretty close to the river downtown, makes it desirable. And a project in Canada, again, a new office building. And that's it.
Wow, thank you very much.
Thank you, guys. Appreciate you coming.
That was very enlightening. Thank you. So for the last item on our list, which is another very, very exciting podium discussion, as we get prepared for it, I wanted to kind of reflect with you on the topic, which is developers as agents of change on the Miami skyline. And I would like to call Susan up on stage to give us some words about a recent, a gentleman in the developer scene that we just recently lost.
Hi there. I'm Susan Kramer. I've met some of you before, and welcome everyone. I just wanted to do a very quick note about a friend of ours. I grew up on the beach, so I'm very proud to be back here and to bring Zak here. And I wanted to give a brief acknowledgement to one of the shapers of the Miami skyline, Tibor Hollow, who founded Florida East Coast Realty in 1956. He developed the first high-rise on Brickell, and look what we have now. So he was one of the first kind of innovators of this area. And Ted was a dear family friend. He passed recently at the age of 96, and his company is now in the good hands of the next generations of their family. And is my panel ready? Can I introduce them? And because of the importance of the role of developers, this is the first all-star developers panel that we've done. And I'm happy to introduce Federico Balestrazzi, principal at Di Simone, and these three key agents of change on the Miami skyline. Thank you so much for being here.
Very good, thank you. Federico, why don't you go ahead and introduce your panel more in depth and get them to get started.
You want to introduce them or you want me to introduce them? Okay, so in pure gentleman style, let me introduce Antonia Divine, which is part of the JDS development team.
No, I'm not. He is. I think he is. He wants to come up?
And by the way, guys, I've been the luckiest one of the presenter because I have the best panel of the whole program. These are the clients. That's why. We have also Kevin Gevanger from 1000 Group. And we have Michael Piazza from Terra Group. And I will let each one of them introduce themselves and talk about the project that they have here ongoing, just so you guys know what they're doing currently. And
before we do this, somebody needs to introduce Federico, actually. Federico is a known entity in this marketplace, in the facade consulting business. He came actually, I don't know, it was like 12, 13 years ago to Miami from Boston. And since then, he has been involved in some of the most iconic projects in a very, very practical manner. One has to hand it to him. He's a very practical facade consultant, and a lot of contractors and developers enjoy working with him. That's why he's also a perfect candidate to run this distinguished panel.
And by the way, I'm very honored that Susan and the rest of the team selected us at Di Simone to be presenting this panel. And I wish I could have had more people, but that's going to be for the next event. And you know who you are. So let's start with Antonia. You maybe want to talk about yourself a little bit and what your role with JDS is, and what you bring here, why it's important, it's interesting. She has a completely fresh perspective, and she's coming from New York, so Let's welcome, Antonia.
Thank you, everybody. I'm Antonia Devine. I'm an architect, and I'm the head of design at JDS, Senior Director of Design and Development. And I work across all of our projects basically to ensure that the design integrity is preserved, whether something is design or construction, marketing and branding, and all throughout the building lifecycle process. Some of the images that I have up here today are one of our completed projects, Monad Terrace, designed by Jean Nouvel and Kobe Karp, and two of our in-design recently unveiled projects, Mercedes-Benz Places in Miami by Mercedes-Benz and Shop Architects and ODP, and Dolce & Gabbana at 888 Brickell by Dolce & Gabbana and Studio Sofield and ODP. So I'll be speaking about some of the construction components from a facade perspective, and then some of the design considerations from a facade perspective.
As you can tell, Antonia has been giving speeches for a long time. She's very experienced and very good at this. This is some of the other projects, and they're going to continue running in the background, by the way, so you guys can appreciate the quality of what these guys do here in Miami. All right, let's go to Kevin now.
Hello, everyone. I'm Kevin Vanger. I'm with 1000 Group. Started my career as an architect. Actually, this was one of my first buildings that I worked on here, the Four Seasons. In 2003, left the architecture side, went on the development side, and been developing ever since. And some of the projects we'll share today are 1000 Museum, Regalia. I think Grace and KPF was here, did a presentation of our building, Tower 36, our office building, and Michael and I are doing Villa Miami together. So we'll touch on a few of those projects as well.
Okay, and last but not least, we have Michael Piazza with the Terra Group. Welcome, Michael.
Thank you. Hello, everyone. So a little bit about me. I'm originally from the Boston area. I started on the general contracting side with a company known as Morse Diesel. Doesn't exist anymore. But started my career up in there, did a few buildings up there, got some arena experience building what is what's called the Boston Garden at the time. And they asked me to come down to Miami. I said, Miami, that's where like old people live. And it was to build the American Airlines Arena. So I figured it would just be about a 2-year stint down here and then go back to Boston. Well, things started slowing down, so we ended up with a project called Espirito Santo. So I went on that project, built that project, and as that was finishing up is when I crossed paths with Terra. And that's when I met David Martin, and he stole me away. So I've been spent 20 years on the GC side, and now almost pushing 20 years on the developer side. And I love being on that side because there's actually more control of what actually happens out there and make things happen. So it's been an interesting career. I oversee all design and construction, and I love what I do. It's a very good passion of mine. So I know the people that have been working with me can see that, and they kind of express it all day long. So this is the first time being on a panel, so it's kind of interesting.
The challenge for me is that I'm the only engineer sitting in here, guys. Everybody else is an architect. So I do have an appreciation for everything that comes from architecture, too.
I'm not an architect.
No, you're not?
I have a civil engineering degree, so.
Oh, okay. Okay, so we have 2 civil engineers. The interesting part about this panel is that you will find these guys on site. These are not guys that sit in the last floor of a building, and they have an incredible amount of experience, and they can talk at length and details and issues in the construction that they all experience and how they're going to address it. So the first topic that we want to talk about is actually the durability challenge. We live in a harsh climate. We have challenges due to weather, and we want to know directly from them what steps are you guys taking in order to design better performing building with the budget constraint that you always live through, and what do you foresee for the near future that you're working on that could probably promote some ideas for the manufacturers that are here present during this conversation. And I'll start with Antonio.
Thank you. I think that, as everyone knows, in Miami, you're dealing with salt, wind, moisture, air, wind, and particularly with the figurative and literal rise of super talls, all of these concerns get amplified. So we're looking, obviously, at developing better details, joints, considering how our facade panels can be increasingly durable. We're also trying to figure out ways how to make these buildings still beautiful and interesting and innovative. So one of the challenges that we have, obviously, is glare in Miami, and how are we thinking about making use of all the beautiful water that's basically going to blind anybody who lives in an apartment if you hit it at the wrong angle. So one of the projects that I had up here is Mona Terrace, designed by Jean Nouvel, who used this I think it was aerospace-grade corrugated aluminum honeycomb panels that were embedded into our facade panels, and that acted as a way to have, obviously, all of the robust curtain wall facade technology that we expect, while ensuring privacy and also looking beautiful. It's highly unusual. I think, Federico, I have one of the pictures up here. But so for us, it's a balance of how you maintain the facade integrity and meet the NOAs and all the standards, while also doing something that is bespoke and wonderful for the residents.
I was trying to put back the picture, but it doesn't work that way. So, Kevin and Michael, would you like to add something to that? Because I know you lived through the challenges.
Well, adding to that is working with proven systems that have already been, all the NO8 systems that exist down here. But every single time, to add to Antonia, is we take that and then we push it to its limits. And then when you go there, now you got to start improving it, because everything can always be better. But it's making sure that you got systems that have the 20-year warranty, and complementing that from a finished paint system, the glazing typically of the 10-year, all your caulking systems. And then making sure at the end of the day, it's really coming down to you can have all the products in the world, but you got to see the execution side, that it's installed correctly, and along with the details that go along with that, so the contractor actually can implement the process in accordance with the contract documents. And having the right QA/QC in place, that's probably one of the most critical things that we have to, and having the team out there understanding what that is. And all that is like contributing to being able to withstand these environments.
I think also, given that all of us wear multiple hats and have various backgrounds, we're able to think about those concerns at one time, not just as the developer or as the engineer or the architect and the contractor, but to say, how do I think about this from the process of design all the way through implementation?
Exactly.
So I would say we on the buildings that we've developed, we traditionally stuck with all of these views, and we broke the rule at 1000 Museum with the design that Zaha had presented. We needed to explore into this new GFRC product in order to capture dancing columns and shapes and everything, and it was, you know, a newer product for Miami, proven throughout the world, but never used on an application like we went for at 1000 Museum.
So I have a question. Okay, let me just start by saying that there's no script in here, but there is a question that is out of the script, and I'm going to bring it to Antonia, just because of out of curiosity, and you don't have to answer, but what I would ask you is, what is the biggest lesson that you learned in New York that you can bring here in Florida, designing high-rise, in terms of durability?
That's a great question. I mean, JDS has two very
Considering
famous,
that JDS has done some amazing project in New York.
And although I would say that all of our projects are bespoke, and we think about them from a hyper-specific site and neighborhood perspective, we have two very visible super talls, Brooklyn's only super tall called the Brooklyn Tower, and 111 West 57th Street. I think for both of those, wind is a big concern, and the innovation of the wind floor is relatively new, and that's something that we need to bring to the table here in Miami as well, with the 1,049 feet just counts as a super talls that Miami has approved. So I think that the dissipation of the wind, all the moment forces that that we have to contend with is the biggest consideration.
Yeah, so for people that think that the developers coming from New York are not accustomed to what we see here, they do see some of the similar challenges. They just see it from a different perspective. So now let me segue to the next question, and I'm gonna put it to Michael. And this one I'm particularly interested because it relates to me. So what investments in terms of engineering to promote better building you see in the near future? What are you guys pushing out there? And what would you like to see from us to be done differently, for your building, to put out a better product? I'm convinced that better design can put better product out there. And that we should always design for the budget constraint that we have. So if we have 100 million, you should design for 100 million. And if you have 20 million, you shouldn't design for 100 and then scale it down to 20. So I'm very interested to this one. Because the result is never what you would like to see at $20 million.
Well, can we start with over-designing our structure? Or no? All right, go ahead.
As far as costs go, that's a totally different subject matter. Because the way this market has been for the past 4 or 5 years, none of us would have predicted where it was. So, there is a way to control design as far as costs, but also design is going to dictate costs. So it's a balance of working that to make sure that the design is not going beyond the ability to build a building. So it's an art of trying to constantly balance those two together. And believe me, I run into that all day long because we always want to go this way, and I have to be the guy that comes in and says no, but the no is defined differently. We got to do it this way to make it work, because if not, it's going to be shelved. But as far as the engineering, you've got different aspects of it. You've got the structural engineering part of it that's going to react to the architecture of the building. But then, the facades of the building, that's all dictated by the specialty contractors out there. We can put a nice facade on the building, but it's got to be built. So down here, we got to work off the NO8 systems. But as I said before, we're going to push those systems because now we're going to take a typical NOA that now gets, okay, well, we want to take this window system and we want to actually, in one building we're coming together, we're taking the facade and making it 3D. And that's a combination of working not only the window wall system 3D, but the slabs in and out. So that now takes a system that really doesn't exist, but it does, and it's got to be modified, so we got to go for a one-time product approval. That's only going to happen through the specialty engineer and through that review process. And, with the helps of like Miami Curtain Wall that sits on the, it's part of our team up front, works very closely with us to advance that. Going back to our Grovic Grand Bay project that we call the Twisted Sisters out there, that I think it took it to a typical 4x8 window wall system, and because we wanted slab-to-slab heights of 12 feet, actually it was more than that, we had an inside a 12'6", which means that the window panel was 12 foot high. We wanted a 5 foot wide panel and slider, and then we had a continuous louver that ran around the building or ahead of that wall. So that's where the building exhausted, the toilet exhaust, the kitchen exhaust. So that raised another challenge. But that entire system everyone was used to working a 4x8 panel, we turned it into a 5x12. We had to not only take into account 12-foot deep balconies, column spans that were separated. Not only that, we didn't build straight columns. We have slanted columns, all angled, so that's adding another challenge to the design. So now you've got the deflection that's going on from slab to slab. All of that put a huge challenge on the window wall design, where that was involving GM&P and E&S, so we had to take into account deflection, now figuring out how we're going to make a 5 foot by 12 foot panel. And in that case, it had insulated glass, so that made the panel that much heavier than a standard panel, and you're still going to be able to open it with ease. We accomplished it, but it took time, and that was all through the special engineering process. So we can do it. It takes time, but you got to have the right contractors and subcontractors and design disciplines involved in the process. We can make it happen.
Kevin, I'd like to hear from you too. What is your experience?
Yeah, I'll just add that as early on as we can bring subs in with our engineers, with our designers, and have all three of them sitting at the table, it really helps through that process. When you have a design that's intricate and you have the structure associated with it, if we know what the stresses are, or what the issues are with the structure, we can make core adjustments, we can make design changes early on, and the earlier we can get everybody in the room together, the better it is for us getting to, especially in this market, with where our costs are. I mean, our only opportunity on cost is designing efficiently, and having those engineers, and especially engineers in the rooms with us, help through that process. Because once we sell, or once that building's out there and we've sold half the building or at least half the building, those opportunities have passed, and we're stuck with the design and the orientations that we have. But early on, we have a lot of flexibility, and we can make adjustments in through that program and those opportunities if everyone's in early on.
Thank you, Kevin. So let me also continue on the same line. With in mind all the maintenance need that we have on this building, what design choices do you think that you put more focus at the very beginning stage of the design of the building and its facade? Because I've never seen talking about maintenance as much as I see here in Florida. And and I worked in Boston and New York in my previous life. But Florida has this topic in mind, which is a reality, and we have to face it. And sometimes we make choices that we're not happy with, but they are the best choice for the building. And I'd like to hear from you, when do you start the process? What decisions are affected, and what do you think you would like to work in the future to even put out a better product? And when I say better product, I don't mean a better product than what you have done, but an improvement because of technology advancement and knowledge advancement.
Yeah, sure. So maintenance for us is not the driving factor. Design, location, use, coupled with scope, schedule, budget is really, when we're designing facades, what's driving those. Maintenance is obviously something that's being considered, but everything requires maintenance. Every facade that you see up here has a maintenance consideration, whether it's cleaning, whether it's recaulking, whether it's painting on some of them. They all have maintenance considerations. I would tell you that it really starts with detailing. If the architects or engineers are detailing properly, it really saves a lot of issues later on when we start constructing these buildings. Bad details are maintenance problems. Good details will move to the quality control with the fabrication, and then the quality control, as Michael was talking about, with the subs and the GC, puts the building in a proper course from a life cycle cost standpoint. And if we do all these things right, and the team that really doesn't get mentioned enough as we turn over these buildings is the engineering group. In this building at Four Seasons, there was an unbelievable engineering group. They come on, we bring them on a year early to really meet with the subs and be part of that process. If that engineering crew, we can do everything right, and when we turn it over to that engineering crew, it's really about their maintenance plans, about their, how they take care of the building. And you can go back and look at, I mean, we walked through 1000, it's 5 years old, and they're doing a phenomenal job. The engineer over there is still the same engineer that we hired. I feel like the engineering crews don't get any respect. Everybody talks about the the great service and the lifestyle and everything that we set up on the front of house side. But without a good engineer in there, we're struggling. These buildings in 5 years can look 25 years old.
I'll add to that. I think each building is different, but you got to first look at when it's designed, what it's going to take to be maintained, and that's from the first thing you got to look at is accessibility. When you got balconies, it's easy. When you got big long drops, you got to look at how the building's going to be handled from a maintenance standpoint, whether they can get on their boatsman chairs or swing stages, or is it something that's going to require some type of mechanical system at the top of the building. I think over the years that from experience now that we look, because we all are, unfortunately, when you're building condominiums, is a post side that ends up getting litigious. And it's always, I think there's goods and bad things about it because you learn from that process as far as how you can do things better. I think it keeps us on our toes about what to expect and being proactive. But the one thing that we need to do that we are doing better is how you implement a maintenance program while you are in developer control of a building association, so that process is handed over to an association that knows what to do and how to maintain this building. You can look at the inside of it, it's the easy part to do. The exterior is that's getting beaten up by the elements. That's the part that needs to be focused on. So if there's a plan with a protocol on what to do and how often it is and what needs to be checked, that's the key to maintaining a building and keeping its life in place that it's expected to do and going well beyond that.
Thank you, and thank you, Kevin, for pointing out the unsung hero of the engineer. There's a few of us in here, and we have been part of some of these projects, but I know other people in this room are part of the design team, and they're doing a great job, and I respect them for all the forensic work that they do and the new design work that they do out there. So thank you again. I have a question for Antonia now, and this is probably a more fun question. So with all the elements that we see in the design for these buildings and all the choices that are making here, if you have to compare your experience from New York and coming here to Miami, what do you see out there in terms of design choices, Antonia, for the near future? I mean, each one of you guys have very distinct work out there, and so you can speak at length probably about it and which direction you're going. I'm just starting with Antonia because I know she's coming from New York. She literally came from New York yesterday, she told me, so that's perfect.
So one of the very interesting things for us and for me coming from New York is the emergence of the branded residence in Miami. This is not really a trend that has caught on yet in New York, although there's probably a one-off here and there. But in Miami right now, particularly in Brickell and downtown, it feels as though you cannot build a building unless it is branded to some degree. And so we are very excited about two of our projects we've recently unveiled. One is a collaboration with Dolce & Gabbana, and one is with Mercedes-Benz. And we've been thinking about how, obviously these have different programs. One's mixed use, one is residential, but trying to figure out how their robust brands can be expressed in the design and for these purposes on the facade. And so that's been a very challenging and exciting design experience for me and for the rest of our design and engineering team. So to expand on that a little bit, right now you have the Dolce & Gabbana at 888 Brickell up on the screen. This to me is all skinny, super tall, like supermodel, ostentatious. The gold balls are really, which is by the way hiding with the mechanical floors, but that's where we have, it looks like somebody decked out in jewels on a catwalk. And the rest of the spaces on the interior are also like a jewel box. It feels very bespoke, it feels very luxurious. Conversely, with our Mercedes-Benz project, they're all about mobility, fluidity, and the facade that we have is a limited kit of parts that's deployed in a much more repeatable, scalable way that feels almost like a Brancusi. You can almost see it in motion. And that's something that we've looked at deliberately at Mercedes as a vehicle in multiple senses of the word company. So that's been a lot of fun.
Kevin?
So I would say over the last 25 years, 20 years, Miami has really started crowning all their buildings. New York was always a place where all their buildings were finished from ground to top, and Miami always seemed to start the ground and never finish the top. And now everything's cladded, everything's crowned. You know, all buildings have a hat on it, and if you look at any of these projects that are up here, all of them are very, you know, you might not like the designer or the design, but you can't argue that they're not all well designed. They're all, you know, they're all design oriented. They all have tops of buildings that, you know, are finished, and that's, for me, that's a big difference on where Miami's gone in the last 20 years.
I think our Dolce & Gabbana project actually has a gold crown.
It has a,
I think it's, yeah.
Has a real crown.
So with that being said, we're moving away from a traditional material that we see everywhere in Miami, and that's the stucco. Stucco is controversial, but stucco has been a choice for many, many years. I know Michael Piazza is an expert at this, so I'm going to let him talk and let us know. And I know that some people here, I mean, you mentioned Miami curtainwall. I know John Medina is here, and they had long discussion about it, a lot of experience, so he can talk about it, and he can say what he sees, what he has seen, and what he sees for the future, and how can we give a better name to stucco, you know, moving forward in the buildings in Miami.
Oh, yes, I would say in a way stucco's gotten a bad rap. Probably the largest reason, it's from an installation standpoint. That's where it starts. I don't think there's anything wrong with how it's spec'd, how it's defined on the drawings, the product. It's typically been used and probably more designed for a two-story building, but we utilize it on these high-rises. And when it comes to these high-rises, we have a lot of challenges with them. These things, when you go to stucco house, you can get it done in a couple days. High-rise, it's going to take months, depending on how high the building is. So you've got the exposure of our environment, and the problem is it's all being done from swing stage. So there's nothing, you know, to be able to monitor it from a QA/QC process. So what we've run into is a number of things where the thickness is not in accordance with its specified as whether it's for the concrete material when it's applied to concrete or block. There's a number of layers that when you put it on concrete versus stucco, those thicknesses have to be applied in accordance with the ASTM standard and the Stucco Institute. The second thing is, you know, defining where dissimilar materials are. Concrete block and concrete seem to be the same, but they're not. They're actually different, so we got to express those by defining those with joints and treating them that way. Unfortunately, they're not well defined on the drawing, so you know, the contractor has a difficulty identifying where they should be, so there's a kind of a finger pointing exercise that goes on. So it really comes down to these drawings need to be defined better, identifying where all the joints need to be, both from an architectural standpoint, structural standpoint. And the biggest thing is when we go to the execution side is making sure that the protocols are in place. All the submittals have been reviewed. There's a QA/QC plan in place, and then the biggest thing is we've lost this terminology out there is having a pre-construction meeting before the actual system starts. Every trade that's going to touch that, making sure that the substrate from the block or the concrete has been prepared correctly, and it's in a position to receive the stucco. Not only that, you get the painter, making sure before the paint goes on the block that the stucco is actually cured right and is in a manner that can be receiving the paint. And you know, we've implemented through Miami Curtain Wall, where John fought me on this for years. I don't want to touch stucco, but now he's part of our QA/QC program, or overseeing it to make sure that the product is installed correctly. That we do go out there and do sound testing. We do the cores, so that we have a log for at the end of the project that monitors or has, you know, it dictates or it has documented the stucco being installed. So that if there's any issues in the future, we can pull it out and here it is. So it takes a lot of work. Stucco can be used, and it is a product that works, but it needs a lot of attention. It can't just be left out there to be installed without having the right processes in place.
I know it's also a function of the subcontracting world and the local subcontracting world. And I'm going to flip again the non-existing script to Kevin, because he mentioned during one of our calls his experience with the local subcontractor and how he solved some of his challenges in the 1000 Museum project, where he had to find the right subcontractor elsewhere and bring him to the local jurisdiction and world to have one of his projects completed. So Kevin, you know, not just in terms of stucco, but also just like you said before, the GFRC experience that you had, the process, and how do you see affecting the design? Because it apparently, it didn't affect your design. You went above and beyond to find the right contractor to do the right job in this neck of the wood.
So that's because it's impossible to do a 700-foot column straight out of stucco that looks good. Aesthetically, like nobody has seen one before. Once it's lit or the sun hits it in a certain direction, it's really a material, as Michael said, that belongs on a house that we've implemented onto the high-rise side because it's $9 a square foot and it is durable and it does have good life cycle costs if it's installed properly. But aesthetically, it's a secondary material from my finished material from our standpoint on the facades. And if we would have, and we mocked it up at 1000, if we would have tried to do those dancing columns out of stucco, Zaha probably would have killed us. You know, she would have never allowed it. We mocked it up. We did do a poured in place. We did do poured in place painted. We did do poured in place and tried to stucco those columns. It was impossible to capture the design, and everyone's seen those columns and how they look. None of them are in the same spot. They dance all throughout the building, and so we had a relationship with a group out of Dubai, and we went to Dubai to sell this concept of using GFRC as a new methodology as formwork to build this project. And I brought the contractor, and I brought the sub and the contractor out there to convince them that this wasn't a crazy idea. Even though it was a crazy idea to import 6,000 panels like we did, we had to sell Plaza, who was the contractor, and we had to sell Capform, who we used to build. Capform built this shell of this building. They've done multiple buildings for me. They've done multiple buildings for Michael. And so that material, once I got everybody to agree that that was the proper material, and we were able to use it from a formwork standpoint. There's no finishing after it's put in place. There's no stucco. It captures the design. And I couldn't imagine any of us on the development team trying to stucco those columns. It would have been, and I did the building to the right also. I developed that with Chad Oppenheim, and that is first exoskeleton building and one of the first ones in Miami. And we did use stucco. We did the best that we could, and this photo makes it look actually very nice. But if you go there and look at it, it's not very nice. So, it's the best that we could do with a 500-foot column, and those are straight. It's very difficult on the stucco side to get the material from swing stages smooth all the way up, and it would have been impossible on the building on the left, at 1000. And again, we did the best that we could with the material on the right. It's not that it's a bad material. I just don't think it belongs in the high rise. It has a place. And by the way, we do use it on walls and throughout podium. This building has very little stucco. New York designed. We have maybe a few ceilings over by the pool deck. 1000 is very little stucco. Villa Miami that we're doing together, very little stucco, and Tower 36, go ahead, keep going. It has probably zero stucco at the moment. So we're using less and less of it, and it's really because of the aesthetic, not because of the life cycle costs of it. Because again, if it's installed properly and maintained, it's a viable material to be used in the high-rise side.
Let me add, because we had this debate on Villa, because when the costs were coming in, they were coming in over our budget. And the exoskeleton on this project, as you can see, is all cladded in metal panels. So we went back and forth debating whether this should be stucco. Again, running into that question that it wouldn't give the building the architecture or the aesthetic value that it has. And we stuck with it and said, we're going to make it work because that's the right product to use on that building. And actually behind it, because looking at, preserving a building, is that those columns are actually being waterproofed behind the panels. So you're not just relying on the panel itself to clad the column from an architectural standpoint. It is protecting the structure since it is exposed on the outside.
And by the way, when we told ODP design this building for us, an exoskeleton, we said that we didn't want it to be as complicated as the 1000 Museum exoskeleton. We wanted it to be simpler, as it moved up the building, because you gotta appreciate Zaha's aesthetic, as magnificent as it is from the outside, posed challenges in sales because every unit has a column in a different place. So you would take somebody to the 32nd floor and they would say, oh, this unit looks magnificent, but the column's right in can I see 40? And the column's in a different spot. Can I see 15? Column's in a different spot. And then they want to go and look at it all again. So when we did this exoskeleton, our direction to ODP was not to dance it around the building all over, but do something. And I think they came up with a very, very, very graceful way of doing it.
And this one perfectly leads us into my last question. And I'm glad that you guys brought up this new language and what you guys trying to do to put it out there. I'm always for pushing the boundaries here in Miami because I see an existing architectural language for buildings that are 50 years old and more. I've seen some common language for buildings in the 80s. And I'm asking you guys, what do you see in the near future? Because I've always questioned, why don't we have something that is completely distinctive in Miami, that develops organically, naturally, spontaneously? And what do you see for the near future in terms of language for the facade systems? We clearly established that stucco is not going to be the winner, like we had in the 80s, but what do you guys see that can promote the new Miami language? Is it going to be the cladding of the columns? Is it going to be more glass and less exposed slab covers? What is your opinion? I'm going to start with Antonia because she feels left out in here. You guys have been talking.
No, I've been learning a ton. I'm very happy talking and listening. I would say I was thinking about your prompt that there's this different Miami language, and I think not only was it a function of the decade that it was built and the related structural advances or material advances that were cutting edge at the time, but also the areas where it was being built. So South Beach is a very different architectural language than Brickell and downtown. So as a New Yorker, I see it's very familiar to me that downtown and Brickell have all of these super talls. I feel very comfortable in the sixth borough, as we refer to it. But I think, and JDS does a lot of this, a very integrated curtain wall panel. I think we're very interested in seeing where that can take us in terms of modularizing and panelizing the installation as much as possible from an ease of installation, but then really playing with what materials are integrated into that panel, whether it's aluminum or glass or different types of stone. Maybe there's a way to get stucco to be pre-installed and applied more easily, but figuring out how those puzzle pieces go together with just a single system of a curtain wall.
Michael, what is your experience?
I think more from a facade standpoint, I know that there's things that, well, I'll give you one example. We have a development that's coming up in the Grove. It's an 8-story building. And, it's going to be, we're actually going to take the facade and clad it with stone. So the concrete structure and the walls, so there's a lot of glass, but the remaining pieces of the building, David really was pushing to explore a stone facade. So that's where we're looking at. That's something different that you really haven't seen on a residential
Is
building.
that masonry, or are you doing
you're really
like a
gonna do
rain
it?
screen or a
What's
vertical?
that?
Is that rain screen, vertical mud set? Like, what's the installation?
It's going to be a typical on clips. It's going to be. I mean, we're going to be treating the structure behind it, waterproofing it, and then cladding it with stone. So, I mean, we have to comply with the whole installation process, but it's going to be clips and anchors. But it's looking at on the base like an oolite material, which is actually going to be about 4 inches minimum thickness because of its characteristics. You can't make it any smaller than that.
Right.
But as we go up the building, we have a thinner material because that's not practical. But that introduces a whole nother layer of complication with the facade because now as you're wrapping the columns, you've got the thickness of the cladding material that's got to die back in. So now our columns are being designed to receive it so the window wall doesn't get hidden behind it. So it's a whole level of challenge that our design team has to work to, that we are currently doing that. That it's so it's another layer of attention that we have to put in this process to deal with. But it's a challenge, so I look forward to it.
Kevin?
So I'll just touch on the roofs. I believe, I touched on it before, the crowns of the building. I think that we're going to see, so we put a helipad on 1,000. We have one approved at Villa. We have one that we're working on in Tower 36. We're big. We did it at 1,000 as just more of a marketing thing. We didn't know if we could get it approved. Took years, 4 years, and now there's a precedence, and we were surprised at how much use it actually got. But I would tell you that, the evolution of technology, deliveries, future of travel, traffic and everything, the roof of these buildings, it gets a lot of use. And so I see newer buildings all providing them. I see older buildings retrofitting to have them. And, whether you believe there's flying cars that are going to happen or not, you do have deliveries via drones that are happening, and having that landing at the top of the building is something that I see. In Miami, they're starting to pop up on all buildings. So I'll leave it on the crowns of the building.
Well, we're in perfect schedule. I guess this is the end of this panel. Thank you so much for coming. I think it was wonderful. Thank you, Kevin. Thank you, Antonio and Kevin.
Great. Thank you very much, everybody. Great panel discussion. Is there any questions from the audience that you want to kind of address? Oh, here we are. Okay.
Here we go. He couldn't resist.
You want that?
Yeah, of course.
Of course, Orlando had to ask a question.
He's laughing already.
Direct it to one person, or? All right, this question's for Michael and Kevin. Is curtain wall a good thing to do on a condo?
Is
curtain wall a good thing to do on a condo versus window wall?
From what standpoint?
Well, the STC rating, the transmission, there's a minimum standard of 50 STC in the Florida Building Code, and it's tough to get that in a curtain wall detail. And we're designing a building right now, and our designers are, torn between window wall and curtain wall. And I was always taught, don't do curtain wall in condos. But it seems like there is a detail that works. Should you stay away from curtain wall in condos, or do you think it's doable?
So, it's it's a big difference in price, right? At the end of the day. If you do a window wall and you snap cap your slab edges, you can achieve a curtain wall aesthetic to a certain extent, depending on how it looks. On the residential side, like a Villa Miami that we're doing, we have a mix. The podium is closer to a curtain wall, hybrid of a curtain wall, and the rest of the tower is window wall. Tower 36 is a hybrid also. It's a curtain wall where you kind of see how the skin works, and then it's window wall behind. I mean, I would tell you it's the difference between $65 a square foot and could be upwards of $150 a square foot, depending on how, like when we did this building, curtain walls were affordable, $45 a foot, and KPF was doing the building right next door, and that was $100 and something a square foot curtain wall, which is still arguably the nicest curtain wall building here in Miami, you know, at Espiritu Santo. So it really, I don't know if it's a matter of getting away with one or the other. I think you can use both in any application. Like here, it's all curtain wall, but window wall is, you know, just a, you can achieve the same look from a design standpoint, or a very similar look, by snap capping the edges and, you know, of the slab edges and having it, instead of having it appear seamless.
Espiritu Santo was done with a curtain wall, which was a mixed-use building. But you got to worry about PT cables, because if one of those goes, it's going through the curtain wall system. We have our project over in Bay Harbor, King Concourse. We have the office component. It looks like there's a window wall, a curtain wall system on the building. It's not. It's a window wall system. And we have the glass coming in and covering up the slab cover, so you're achieving it, but you're not paying the cost of a curtain wall system. There's no any STC requirements or compromises on there. I don't know of anything, and the man right there to your right will be able to answer that even better, you know, as far as the use of it. But I think, you know, Miami's been more of a window wall system. It's worked. It's withstand a lot of the, you know, the hurricanes. I mean, I saw what happened when Wilma came through. And the buildings with curtain walls suffered more damage than the buildings with window walls. Because the Espiritu Santo had a lot of damage done to it, but the surrounding buildings that had window wall, not a single thing was done to it. And it's more of what I think is how the surrounding buildings had contributing factors to that. But yeah, I mean, I think the big thing is a cost factor. I don't know, I can't comment on the performance difference as far as sound, but I think that given that Miami is a big PT slab that you've got to worry about, because broken cables happen all day long.
You know, we're also using insulated laminated glass now on the window wall systems.
Yeah.
So it's as close to a curtain wall when you open the doors, or sound-wise or performance-wise, where we used to just use laminated glass. Now you have the air gap, and so it's very, glass product that we're using is equivalent to a curtain wall system. It's just one hangs off the edge of the slab, one sits on the slab. But you can achieve the aesthetic. Cost-wise is much less, and you have the same glass.
But you've got all that fire safing to deal with from slab to slab.
Yeah.
Very good. We have another question here.
I just want to add to that, perhaps asking from the other way around. It's in a lot of different places, it's very uncommon to do window wall, particularly for large buildings. So I'd be really curious to understand from your guys' perspective. Window wall is very common here, and I understand it from an impact perspective. As soon as you go to taller buildings, where is the cutoff point where actually installing window wall at every level really becomes very inefficient, and where does curtain wall become, you know, not more expensive, and perhaps also from a detailing perspective, from a waterproofing perspective, and from a risk perspective of different trades, a system that is on the safer side?
There's a lot of questions in there.
To answer your first question, we actually draw it both ways. And really up until the procurement stage, we make sure that it can work in both ways. We don't know, based on what the market's doing, whether window wall or curtain wall is going to be more expensive, or if we're going to end up, at some point the decision will be made for us, but we typically try to make our buildings work, be able to do it in multiple systems.
I mean, we've never been able to make the curtain wall, even from a speed and efficiency standpoint, come in from a budget less than a window wall. ever, except maybe back in when we were doing this building, but it was a New York design building, and he looked at window wall, and it wasn't the aesthetic that they wanted. So there's a significant delta, and the glass is loaded onto the floors, whether it's window wall or curtain wall, and it's dropped down. So, I'd be interested to know when we talk to our glass guys, which one, if they can move from an efficiency standpoint. But it's a big delta. It can be two times, three times, at least from a cost standpoint between window wall and curtain wall.
Well, if I can add to that, also this area, not only in terms of traditional construction from the structure, but also for installation purposes, it's more accustomed to put in curtain wall and or sliding glass door on balconies that attach to curtain wall window wall and sliding glass door rather than curtain wall. So from an installation perspective, you find better installer doing that than installing curtain wall in general. That means what? Most of these buildings, when they have condos, you have balconies anyway. And when you have the transition between the balconies, that's when you go to either window wall or sliding glass door. Yeah. So you have to design a custom modeling for that. And that's another waterproofing challenge that we have seen.
Okay, great. If there is no more questions, here we are.
I would like to ask the developers how they see Miami growing in the next coming years.
You want to start with Antonia?
Ooh, that's...
I don't know how to answer that question because it's obviously growing a tremendous amount. There's traffic, detours absolutely everywhere. You can't get around without being in front of or stopped by a construction site. I think we would all say that obviously there's tons of residential, there's tons of growth here, but the infrastructure has to catch up. And I think that's been a big limitation, certainly from a, transportation perspective, but also the people infrastructure of the city. Everyone fled from the pandemic and came down here. And so I think you need to, whether it's increasing the rapid transit zones or increasing public transportation, all the new roadways and systems that they're building, I think that has to happen.
Storm drainage too.
Storm drain, yes, no, but I think all of the lifeblood systems that make the city work have to have significant investment and focus in order for all of these beautiful buildings to be inhabited and lived in and appreciated as much as we all do here.
I would say exponentially. There are companies, we've gone from, there was just a presentation here, I think a week and a half ago or 2 weeks ago with ISG, and Craig did an unbelievable job explaining how we're not building fast enough. We can't get buildings built fast enough, for all of us, I guess. We don't have enough units coming into the market here fast enough to deal with the growth of the companies that are coming here. And Miami was traditionally a second home purchase market, and now it's become where all these companies are moving to and moving from Chicago, New York, California. And in the next 2, 3, 4 years, they're saying that we have gone from 100 companies to 200 companies to 400 companies that'll be setting up here in Miami. And he's begging us to move faster. Things just aren't moving. Like we're not building fast enough, and it's a combination of cities getting all of our approvals are taking a lot longer, buying the jobs, getting the assemblages together. Everything's taking longer, and it's just the growth. It's Miami is off at this point. It's off on growth. It's pretty amazing what the city has become, and all the infrastructure and everything needs to catch up for sure. FDOT's trying to do what they can with these highways, but these are they say 4-year projects. They're 12-year projects. Like that bridge isn't finishing anytime soon, right? They say a couple of years. We talk to them all the time. It's going to be done in 2026. 2026, it's going to be done in 2050, maybe, right? When flying cars are happening and all these roofs are retrofitted. So it's on an unbelievable course what Miami has done. the architecture and the buildings have evolved over the to a place, and the city is, in just a prime place. And not just Miami, but South Florida. It's really a South Florida market. So it's very exciting to be, a part of that process. Someone asked about the GFRC?
Very good. So I think we should keep it at that. Thank you very much. That brings us to the closing. That's the bad news, But the good news is the next item on the list is actually the reception, right? So thank you very much all for coming. I'd like to thank you as an audience. You were great. And also all our presenters were phenomenal. I think we are all walking away with a lot more information that we came in here this morning. And that's something that we should be all grateful. And then also we have the opportunity to network with one another in the industry, which is one of the most important aspects of conferences like this. For the presenters of this session, if they could please stay, we have the plaques to give you guys too. And then the rest of you can start enjoying the reception after some closing words from Ahmad.
Hello. So thank you all for attending today's event. I hope you enjoyed today, and I hope it was informative. A round of applause for our event host, Attila. I think he did a fabulous job in hosting the event. Thank you. As I said this morning, we've recorded today's event. We'll share a YouTube link of all the presentations we've got permission to share with you a week from now. And until we meet next time, we look forward to meeting you now at the networking reception, courtesy Ekasali Oklahan and Kurare. See you all in some time. Thank you all.